All right, everyone. Hello and welcome to the Clubhouse Chill Session. Today, Dr. Mike, Shane, and I are going to go over and discuss the happenings of the celestial theody.
Mike, that Great Pyrenees is nuts.
I'm in the building. What's up, Cat?
Testing 1, 2.
Good evening, Linnell.
What's
Liz?
today's card?
Oh, today's card would be, where are we at? We're at the 24th for sure, yes? It's a 4 clubs day. Straight through, we are in Leo first decan. So it's 4 clubs, 4 clubs, 4 clubs. Stable, mental.
Gotcha.
So,
You know what I was gonna ask you? I was thinking about something. You said my card is one that has to keep moving. Is that what you said? It's the Ten
the
of Spades.
Ten of Spades is group leadership. So I can't remember what the movement. It might have been the 5 that is in your decan card, possibly. That is with
Okay.
movement. 5s are all about movement, and I think you have a 5 as your decan or your planetary ruling card.
Yeah, you was like, yo, you got to keep moving with so either job or physically. Like, All right, so that was a decking card. The 5, I got a 5 as a decking card.
We all got to stay moving, Linnell, but if you stop, you die.
Bruh, I know, right? This is some bullshit. All right, I was thinking about that.
What's up with the Queen of Hearts? What's going on with that? What's happening
It,
next to
it
that
means
one?
you're a homosexual. Knock it off.
Oh,
You're a girly man.
Dang.
That's so messed up.
You're a queen at heart, Chilla.
Straight violation.
You're a queen at heart.
Oh,
Microphone
Man,
check.
First Chris got on you, now Linnell get
Can you guys hear me in the Clubhouse?
shit.
All right, Liz, Linnell, everybody. I feel like we got most of the people in here. Shane's in here. Dr. Mike, Alan.
This is gonna be great.
Yeah, for sure. And people are still piling in. And yeah, we're just very grateful that you guys decided to pull through for another sesh. And like I said, for people that weren't in here earlier, the app has been glitching a bit. So it's not you, it's the app. So you may have to swipe out, come back in. But, you know, just as far as a heads up. Oh, and the feature now is, and you don't have to have a subscription for it. As you notice now, your PTR, aka your profile picture of your choosing, you can now add multiple profile pictures. So say if you wanted to do a little slideshow, you also could do that. I know, slow updates, but Clubhouse is getting there.
Nice.
Microphone check.
Yo, by the way, you got this dude. Some like looks like a bot message. I'm not sure how you guys moderate
Mic
in
check. Mic check.
Clubhouse.
All good. We can hear you.
Oh yeah, they put those messages and then they either get removed from the room right away or they just dip out. Yeah, they happen all the time, and it's usually like from the crypto spaces or finance spaces.
Yep.
Those bastards.
Dude, is that D3 hanging out before everyone?
somebody with a
Yo,
mustache
yo,
status.
what up?
Been in here
Oh,
like
whoa,
pre-gaming or what?
you sound so different in here, bro. I didn't even know it was you. What's up, bro?
What's going on, fellas?
I can't see your
What's
name.
happening, y'all? Peace to the
Who are you?
cars passing through and whatever, y'all.
He's bad mad in here.
All right, that's why I scrolled right past it 7 times looking for D3 or whatever.
Oh, my bad. That's
what's the deal with my
thanks
boy
for putting on.
Sacred, man? He don't do he don't run Twitter anymore.
I'm
He's
on
just
there.
MIA.
I'm there.
an idea. I just took a screenshot of it, and I'm gonna put it in Discord in Dr. Mike's DM.
Oh, then that's
Already
perfect.
been
Yeah.
done. Dr. Mike has already received it.
You guys are
I was
awesome.
just
Awesome sauce.
Cat, that's why you're the boss.
I was just wondering, like, did you ever the other day everyone was chatting about the moon and they were talking about like the phases of the moon and like did that get cleared up and did people understand after what it was and how it works?
So we'll definitely get to those questions. I just want to get these introductory things just like out of the way. And thank you again, Kat, for sending those over. And thank you. That was definitely a way better idea just to send them straight to his DMs. If we could just get that out of the way, and then like the floor is open. That's all.
Awesome. Did Mike make it yet? Oh, there he is. Yeah,
Maybe
whenever
he's
you're
having
ready.
mic issues.
Oh, yeah. Oh, he hasn't not spoken yet.
Mike, are you? Oh yeah, you can't answer if we have mic issues. Is he? I
It's on
think
the
he
bottom right.
doesn't he use Club Deck too? I thought we set him up.
Let's bring back the question. It's like a bear or a man. Yes, that. That's
Dr.
first.
Mike, you want to try testing out your mic? It's on the bottom right to unmute if you're on a
Yeah.
phone.
Okay, can you hear me?
Yes, sir.
All right, great. I lost my audio momentarily, so I had to leave and rejoin.
Welcome.
Yeah, but I wanna ask that shit back. So they always say like, women always choose the bear than a man. They always like, I never see a building built by women, all from start
What
to
the hell? What's going on? Am I in the right
Okay,
room?
apologies. Yeah, okay,
Oh,
guys.
okay.
We have to be
Shit.
a little bit faster with that. Anyways, no worries, no worries, no worries. Back to our regular scheduled programming. So yeah, Dr. Mike, welcome once again. I believe Kat had sent you over some questions. They were kind of like some introductory questions, some refresher questions, just for our listeners, and anybody who's new to the conversation regarding these updates. And then, we'll get into it. Floor is open. But yeah, I just thought that it'd be fun to just kind of open up with some of those questions. So not sure if you have had an opportunity to open, I guess, the DM to just see what the questions were.
So I did open Cat's DM and I read the questions and I thought about them a little bit, and so I'll just wing it as you ask them to me again.
Oh, okay. Yeah, we can do it. Okay, guys. So we're just gonna start from the very top. Just these are just like 5 questions for Dr. Mike Heffron. So, question number 1, Dr. Mike, what is a celestial theodolite, and how does it differ from a standard theodolite used in surveying?
Celestial theodolite, in a lot of ways, is very similar to a standard theodolite, a terrestrial theodolite that's used for surveying. But unlike a terrestrial theodolite, which is a physical device, celestial theodolite's more of a concept. So in a terrestrial theodolite, you have an eyepiece and you look through that and you sight whatever you want to see. Well, in the celestial theodolite, the eyepiece is either your eyes or binoculars or a telescope. And for best results, you probably want to use a telescope, because what the principle of the celestial theodolite is, we use a mountain peak as the horizontal crosshair, and we watch for stars to be occluded by the peak. And then once the star is occluded by the peak, we note the time, and we already know what the peak is. So you can visit Stellarium or your favorite astronomy tool, or get out the nautical almanac and calculate yourself. But what you want to do is find out what was the elevation, and we're talking about the true elevation of that star at the time it was occluded, not where it appears to be, but where it actually is. And using that elevation, that's the angle your celestial theodolite just read. So now all you have to do is take the tangent of that angle, multiply it by the distance to the peak, and that tells you what the rise of the peak is above the level of the observer. So add to that the altitude of the observer, and now you have the altitude of the mountain peak. And unlike terrestrial theodolite, which is affected by refraction and atmospheric conditions, the celestial theodolite is not affected by any of that. So you get an extremely accurate, extremely repeatable elevation of the occluded star that you can use to calculate the height of the peak without any interference from refraction.
Yeah, no, and I was just gonna say he basically summed up the other couple of questions. Sorry, Jamal. Oh, not sure
So
if you.
you said my name? Sorry, no, that wasn't me. It's
Oh, I
some.
thought that you were okay. Never mind. Okay, so yeah, Dr. Mike, and thank you for summing that up. Like I said, you did that beautifully. So you basically answered basically most of the questions on here. I was there. There's two. So one that I am going to ask, and then one that I'm going to leave for our boy Coffee here. I'm sure you're familiar with Coffee. I know Ether causes. It was something that was discussed earlier, and before I'll let you guys get into it, after I ask the other question, but it's regarding the J factor. So that way you guys can get into it. And just basically like for the room, what I'd want is just basically, what is the J factor? Why did it need to come up for the correction, et cetera, et cetera? What would be the, on the opposing side, AKA the globe side, why do they object to it? Why are they trying to say that it could be something else, or it could be, an error, et cetera? But the question that I'll ask you, and I'll let you guys do the J factor. So now that we've had a couple of these and there have been updates, and I know that you guys are constantly updating online, have there been any discussions, and I'm sure this goes without saying, but just for the room, in Ether Cosmology Discord that have helped you refine your theories or led to adjustments in how you're interpreting the theodolite data? And this not only goes with just talking to like the flat earth side, Dr. Mike, also even like when you have objection or pushback from the globe side, like how does that help you refine your data?
So I think the biggest way that it helps is it lets us know what people are having trouble understanding. So some people accuse me of rambling, which is not an unfounded criticism. And so I'm trying to be more precise, try to listen to the concepts that are confusing or being misunderstood, and in ether cosmology, when we have discussions, it's usually what's a better, less confusing way to present this. Um, uh, and my professors, when I was a student, they were always criticizing me for I do what they called a logical leap, where I just did not explain something I thought was so obvious that everybody would understand it, and it didn't need explanation. And they were constantly calling on me on that and asking me, "Well, how'd you get from here to there?" And so Q&A helps with um, uh, finding a different way to emphasize important concepts that may not be well understood. And when we get into the J factor, that's going to be one of those that people are totally misunderstanding the purpose of the J factor, and they misportray what it's actually doing. And in my mind, the whole concept is real simple. It's actually your question reminded me of something I should have said earlier. And I apologize for answering too many questions at once. Because that was an unintentional, but the a very very important part of the uh, celestial theodolite that I kind of glossed over was the importance of the mountain peak as a crosshair, because the before the celestial theodolite, people would measure mountains with terrestrial theodolites, and they'd get all kinds of different altitudes, and they were generally portraying those as globe Earth altitudes, um, and the original intention of the celestial theodolite was, well, we know the height of this mountain peak, so if we see the mountain peak occlude the star, that's a good horizontal good horizontal crosshair. It's an object of known height, and now we can just look up at the elevation of the star at the point that the peak occluded it and see, is that a flat Earth angle or is that a globe Earth angle? And from the very beginning, it was all flat Earth angles. So at the time, my whole history has been a globe Earth guy, and that's what convinced me, no, the data is showing the Earth is flat, or that could not have happened. It came out the one angle it could not possibly be if the theory that the Earth were a globe was true. Because what I was doing is I was trying to refute the null hypothesis that the Earth is flat. And I couldn't refute it because it came back with a flat Earth angle. So, and after that, I went on to other mountain peaks, and it's the same principle, and it's the same pretty simple every time. And I don't know if I managed to answer the question somewhere in there.
Hey, real quick. So, I know Liz gonna hop back up in here, and I know Coffee had a question, but I think you brought up something that I think it was gonna be my question, right? Because a little birdie told me something, and I was just curious as to, I said, you know what, I'm gonna ask him next time he's around. Is it true that you were a secret flat earther before you started the
Oh, there
Celestial
you be. You stole
Theodolite?
my thunder, bro. I was literally, you stole my thunder. I was setting it up. You told me, hold on, this is
Where
my
you?
setup. Hold on.
Go
Hold on,
ahead.
I got a different setup. Let me ask.
Go ahead. You go
Because
ahead. You
this,
go
I
ahead. Go
found
ahead.
myself defending Dr. Mike the other day, and I said, wait a minute, why am I defending this guy? What do I really know about this guy? Because rumor has it that you played a really long game, like you were really a secret flat earther, right? Because I told someone that you weren't really a flat earther, and they said, well, that's what he says. And I said, well, it seems like the rumor is that you played a really long game to do this flat Earth reveal and reinvent yourself as a flat earther. So I guess you went house shopping on Zillow to cherry pick a house that had mountains outside that landed in a range of cherry picked data that would match a flat Earth observation, so that you can come up with this whole celestial theodolite ruse. Because that's kind of the rumor, what the rumor mill's been on Clubhouse has been.
What?
So I said, wait a minute. I had to think about it for a second. I said, you know what? I don't know that that's not true. So let me stop defending this guy and give him a chance to defend.
I mean, if you were going to no hypothesis it out, that would be the way to do it, right? Like,
Hey,
can you falsify
I
the
can't
alternative?
falsify that. I don't know. So let me ask you. Let me ask the guy in the flesh. Like, is
Let's
that
get to the
true?
bottom of it.
So
So
Zillow has
I'll give you
occlusion spots.
I'll give you a really direct answer to that question. No, I was not a secret flat earther, and I lived in this house for 11 years now. Um, and at the time, I was working for a special access program that's heavily involved with satellites. And in fact, my whole career, I've been involved with satellites. So I was definitely very indoctrinated into believing that the Earth was a globe. And until I got hooked up with the Ether Cosmology Group, it never occurred to me to ever take the concept of a flat Earth seriously. But I began listening to their debates, and they were really interesting. And the gears in my brain started whirring, and I came up with this idea I thought would be a way to actually that maybe it could be successfully tested. So I asked Alan about it over at Ether Cosmology, and he thought maybe this technique had promise. And I just started taking videos with my telescope and analyzing the data. And uh, when my first few measurements came out flat Earth, I was definitely surprised. And I think by the second mountain peak that I did, I thought maybe I started with Pikes Peak, and I thought maybe that was just a fluke. And by the second mountain peak I did, um, that was enough to make me realize
Is that me?
Did
that
he cut out for
it's
everyone
that the
else?
Earth is flat.
Yeah, we lost him for a second.
We lost you
Mike,
for
we
like
lost you
five or
for
ten
about 10
seconds. So.
seconds.
Mike, after you said
Well,
after the third measurement, then and then it went blank.
oh, okay. So after that measurement, that's what turned me into a flat Earth convert. That's when I realized the data is clearly showing I cannot refute the null hypothesis that the Earth is flat. Therefore, the Earth must be flat. Um, and with more and more data, it's just becoming clearer and clearer. If you look at any of the graphs in any of my spreadsheets, you can see that the globe Earth measurements are above and below us, but the flat Earth measurements are all right around
Is
small
that me?
deviations from the zero. Oh, sorry, what was that? If there was a question there, I
That
missed
me?
deviations from the
Nah.
zero.
So hey Mike, have you ever heard that the universe always balances itself out?
If there was,
You ever heard that
I've
concept?
heard that said.
See, so
I've heard
to
that
me,
said.
it seems like because they took Jaren, the universe had to balance itself out, and so it forced you to come over. So, you know what I'm saying? All right, I'm cool.
But
Go
Dr.
ahead, though.
Mike, what kind of sorcery is going on here? How is this method immune from refraction?
And
So
here we go.
that is that is by design. I, as I began looking into what was being done, I realized refraction is the only thing um, that's giving the false appearance for terrestrial measurements that the Earth is a globe. And all, the illusion of a globe is all in the refraction. So my first thought was, well, what can be done to eliminate refraction? And that's what I was looking out the window at Pikes Peak at the time, and I was thinking, well, if you watch stars being occluded by Pikes Peak, I know the altitude of the peak, um, and um, when the star goes away, there's no refraction involved. I know that that's where the starlight intersected the peak. And so now it's just a matter of looking at what was the elevation of that star. And lo and behold, the elevation of the star is the exact elevation that the flat Earth angle should have been from my house to that peak.
See, the thing was, once I first heard it, I thought it was ingenious, right? Obviously, but I didn't have my hopes up too high because of, like, for instance, the Mount Canada observation, where I've heard, countless experts and science people come, globe heads come in and say that the mountain that's blocking the sunlight and creating a silhouette, that's being refracted up, and so is the entire sun. It's that sun's also not where you see it; it's completely under the horizon, and all of that entire scene in front of you. So there's a refracted thing blocking another refracted thing. So once I heard that, I said, "Oh, there's no, they won't. It ain't shit for them. They're gonna refract the mountain and the star wherever they need it to be with with carte blanche and no qualms about it." And I knew they would, and sure enough.
Give them their refraction, and it's still off.
Exactly.
Yep.
Which is
Or you
why
can
the
do
whole
it.
notion that Mike like cherry picked somehow by using the. I said to me, what I see, like I haven't gotten, I'm math lazy, I haven't combed through all the data. I'm just kind of listening to the argument, and obviously, as far as logic and like Occam's razor and reasoning goes, it seems like the flat earthers are having a degree of randomness here that the globe earthers they can randomly pick places and use their assumptions and make predictions, actual true predictions. And it seems like the globe hasn't done that yet. So until I see that from the globe, I think the flat earthers are proving here that they have a better, more salient, predictive, more efficient, by definition, predictive model, because they don't, they can make predictions and, with less. You need more to act like you're making the prediction. It's not really a prediction at all.
Or you can do it the John way. I don't know if y'all familiar with John Mallinckrodt. You can do it the John Mallinckrodt way. And we're going to start with the answer. Like, just do it my way. We're going to start in Stellarium, and Stellarium is going to tell you where the star will be. And then, like, so it's like he goes back. He starts with the answer and goes backwards. So,
Yeah, one other problem that our Globe Earth friends have is because their methodology is so heavily dependent on refraction, which is all over the place depending on temperature and pressure. That's what makes it hard for them to predict anything. Um, and my very first measurement, I just put my little telescope on Pikes Peak and let it record for a couple of hours all the stars. And after the fact, I looked up where what was the elevation of those stars when the peak occluded them, and that that's probably when I started considering maybe the Earth is flat because they're all coming back at a flat Earth angle. And so, but somebody could drop you in the middle of nowhere. You cannot even, you personally cannot know where you are, and you can watch a peak occlude stars and write down the time. And if they know where you are after the fact, they can verify whether the elevations of those stars give you the proper altitude for the peak. So we definitely have that. We have very, very good predictive power, whereas our Globe Earth friends can't predict because they're hostages to refraction.
Okay, so what do you say to someone who says, well, right from the onset, you need data from a model, right, from a celestial sphere, or from a what do you call it, stellarium model, and that ipso facto equals globe, right? That is a globe, so we win. What do you say to someone who wants to claim the positions of celestial bodies as exclusive to a globe? How do you prove? I mean, how do you, how do you borrow what they think is theirs exclusively?
Oh,
Like, what do you say to a person who thinks it's theirs exclusively?
I would love to follow up on that after Mike answers.
Can you use stellarium data and and then somehow claim
I would
that
love to
it
answer
relates to a
that
flat earth?
after Mike gives his answer as well.
Sure.
So I don't consider myself an expert on how to answer that question in a meaningful way, and that goes back to my problem with not always being able to explain something that I consider to be so obvious that I would think everybody would know the answer to it. And this is one of those things. I know they've latched on the celestial sphere as theirs exclusively, but that's actually a fairly recent development when you research that really only goes back to Ptolemy in the late 1400s or early 1500s. And before that, virtually everybody assumed that the Earth was flat, and it wasn't until roughly 500 years ago that people began thinking, well, maybe it's a globe. And even when Christopher Columbus allegedly sailed to America, they were worried which was just barely over 500 years ago, they were worried he'd sail off the edge of the world. So I don't think this is something they own as much as they're trying to convince people they own it. And now I'll defer to Alan, and he can give a much better explanation.
Awesome, dude. Well said. Give me 1 second. Let me pull up my Canva real quick. So I'm having Kat put some links in the chat for us. One of the links is the Discord link to the Flat Earth Gang Discord. Nothing official has been done there yet, but there is a Discord that's been constructed that will be useful in a future time. But there is also references to images that Shane's going to be covering tonight and things that I'm about to reference right now. So if you want to take a look at it later or whatever, it'll be permanently parked there. And then it'll also be in the chat here for the Clubhouse permanent lads. But what I found on Tuesday was that the prior to like the mid 1800s to early 1900s, the Buddhist in Japan, the Shintoist in China, and I forget the other one, but basically every Asian culture was a flat Earth geocentric cosmology. And specifically during the mid 1800s, uh, when the Jesuits came in, they pushed heliocentrism, the Earth as a globe. They pushed the solar calendar, and Christianity. And the Buddhist monks started using like their own optical arguments against them to show how unreliable their conceptual model was, because the way that the Buddhist monks had conceptualized it was that, you know, the world that we see and that we live in isn't exactly the true world, right? And especially when it comes to the heavens, what we see is like obfuscated and apparent to us, and there's a true heaven that, you know, that the motion of the bodies belongs to. And then what you can see here in the Canva link that Kat just posted, that first image on the bottom right, you'll see a little disk model with a bunch of celestial spheres in it, and it's just the hemisphere. Right now, keep in mind these are flat earthers with a celestial sphere model, just using uh, the top hemisphere, because all one observer ever sees at one time is their hemisphere of the sky. When the stars are out of your vision, right? There's two options. They could be beneath your feet because of Earth ball curve or something like that, or it's an optical effect and they're out of your vision and they're circling above you. Now, these guys all had determined that it was the circling above you, and using the exact same model, they were all able to navigate. You can look into the story from, so keep in mind, like, this is 1800s, like mid 1800s. These guys were flat earthers. They could all navigate. They had uh, their empires have been sailing and all that. You can look into the Chinese expedition in the 1400s, even, where they basically sailed around the entire world using worm line sailing, and that was obviously redefined when Mercator came around to make it about being a globe and all that. And Shane can touch on that for the specifics, but the point is, using the using just the what you see as your hemisphere, they mapped out the entire world and was able to navigate it. And so that's not mutually exclusive at all, like the celestial sphere. What is mutually exclusive is when these Christians came along, they introduced the terrestrial sphere, right? So what Mike had just touched on with Ptolemy is the merger of the celestial and the terrestrial sphere. So that's merging these two models to relate positions of the stars to positions on the ground. And previously, navigation was done by going to nodal points and then adjusting your bearing, and then just following your bearing to another point, another known point. And people had their own maps, their own charts, etc. And then there appeared to be one universal one called the Perry something map, and that was there's like a fragment of that, and it uh, details where the Chinese were when they were doing their expeditions in the 1400s. So there's
The
a long
Perry Reese map,
history.
right?
Yeah, the Perry Reese map. Thank you. There's a whole history of world navigation. And anyway, we're told a specific narrative of like this terrestrial and celestial sphere narrative that's presented to us by the Royal Society, and that's basically it. The way that they made that model work, of course, was using a fictitious observer tying tying all the positions in time to a specific uh, point, and then adding 15 degrees per hour to that. So we're actually using we're using their framework to test it, because units of measurement are derived from their coordinate system, from the latitude and longitude system. A meter is a ratio of a terrestrial meridian being a longitude line. So they
It's like 1/10 millionth or something like that, or like the minus
one
that.
exactly 1/10 millionth of it. So it's internally self-consistent. So if you're referencing the system within it, you will never find a contradiction. So that's why
Man, it's a
Mike.
loop. I tried to explain this earlier. It's like a perfect loop that they interlocked and interwove all of the shit into. So
Yes,
got to
sir.
be
And Mike,
really fucking keen to pick up on it, Otherwise, your end user experience, it all just works out swimmingly, and you would never really ask any questions.
exactly. And like my boy Copernicus once said, if you're making a model based off of apparent positions of bodies, you could say anything you want, and whatever is easiest to teach is what we're going to use, and we'll use whatever we need to make our math work. And that's in regards to refraction corrections to change the positions of the stars to where they need to be to make sense with 15 degrees per hour, to make their coordinate system work, because they relate time to angles to the stars and vice versa. So if you know a specific time, you know what angle that star's at, because they took snapshots of all the stars that they use for navigation on the first cusp of Aries, and then you add 15 degrees per hour to that. Well, that's where they come up with the concept of a true position and an apparent position. So the true position would be that star's zenith position on the first cusp of Aries. If somebody were standing directly under it and looking up, where it would be, and then adding 15 degrees per hour to that. And then so when you are at your position and you're looking at it at some angle, well, it's not going to be exactly one to one the same. So they have these corrections that they apply to make that angle adjustment correspond to the correct time, if that makes sense.
Right. No,
It's
I
like a
mean, I tried to explain this to someone earlier. Kind of asked me, I forget the name of the word, but it's like, so you have your zenith star, and I guess it's the antipode star right under that. I forget the name. Somebody hit me
the
with a
nadir.
term. Yeah, the nadir or whatever it was. And they were kind of trying to ask me about that, as if, that obviously means that it must be a terrestrial sphere as well. And I was trying to explain, to me, it's just like, hey, if I'm standing in one position, I have an observatory here, and I see a celestial object, travel, it entered my horizon on this azimuth at this angle, it left, and I clock it on the time that it comes back around. Like, I can just treat it like a circle mathematically. I can just create a circle with a period and create like a ratio. And whether it went under my foot because of ground curvature, or whether it just went that away and came back around, doesn't really matter to me, as I construct a model that just kind of describes its orbit, right? In terms of its
I do
period.
have I do have a question though, Jamal. Like,
Go
where
for
we
it.
are, where I live in New Zealand, right? There is a particular time of the year. It's called Matariki, where there's stars in the northern sky above the mountains that they're only visible for like a couple of months of the year, and then they disappear again back over the horizon. Yeah, but no, but Shane, that
I got a
wasn't
question
anything
for
to do.
Mike real
That
quick.
that wasn't anything to do with my question. Like, the question was why?
Hey, please
Uh,
don't interrupt me.
oh, for fuck's sake, guys, fuck you, sake.
Hold on, man. We have guests in the room today. You have that type of attitude, just having a good conversation. You're trying to give it.
But Jesus, I was only asking one question, and it was related to what you were talking about, and I was just wanting to know. And then the two of them, like Jamal and fucking Shane, dismiss people. You'll never have a fucking group big enough with this attitude.
Who did I dismiss? I didn't even come off the mic. Why are you saying my name, bro? Relax. But we could
What's your
keep
cool?
moving right along because I don't
Or
know what's
never mind.
happening. Yeah. I don't know. Is anyone? Did you satisfy? Like I don't know what's happening, but I didn't. I didn't interrupt. I didn't. You just asked your question. I didn't. My name is being brought up, but yeah, like the question I had was right. So I understand these are really big undertakings, right? It takes a lot of the king and queen's money and foot soldiers to actually do this. My question, so I understand why we're stuck kind of retro, like kind of reverse engineering what was done, and we're stuck with this coordinate system that they put together for us. But my question is, they won't admit it outright and say, "Hey, it's a philosophical assumption that we were trying to flesh out." What would they say is the reason or the necessity? Like I guess since Ptolemy's days when he's coming up with this in our geography or whatever, he's coming up with this two sphere model where you have a terrestrial. What would be his reasoning for going with a terrestrial sphere? Why couldn't you use a celestial, or two celestial hemispheres or celestial hemisphere in a terrestrial plane and then create the system, right? What would be their argument or their steelman? How would you steelman their justification for going terrestrial sphere?
Okay, so in order to relate it all into a unified coordinate system that they could project that's spherical, they uh, they have to tie all those positions to they have to tie all those zenith positions to a position on the ground, right? And so to do that, they use the fictitious observer to do that at the center.
At the
So
center, right?
so to use their version of the celestial sphere model, you have to incorporate a terrestrial sphere where you can use a fictitious observer for a comparison. Because what you'll notice when you read through these old almanacs and the supplemental correction tables and all that, and like how they came up with them, what they say, part of the transformations that they do are called geocentric coordinate system transformations, and those are zenith position. That's the true position zenith measurement that I was talking about earlier, where they took a snapshot of the sky on the first cusp of Aries to make everything relative to that. So to make the time comparison to get the angles to work, they move you to the center of the terrestrial sphere, and move the celestial objects to the radius of that. So the way that they'll word
Wow.
it, or an easy way to get you to conceptualize using the two, because if you're going to use their version of it, you have it corresponds to time, and to correspond to time you have to use their positions. So let's see here, what was I going to say? The
Okay.
geocentric coordinate system transformations. That's the comparison where you find out where the star is at now, so you can find your latitude and longitude. Because if you know the time, then you know how much that star has moved since the first cusp of Aries with respect to 15 degrees per hour, and then you know where that's at, or then you have your Greenwich reference. So when you add your local time to the 15 degrees per hour, accounting from like the zero longitude, you get where that star is at, and that'll be your longitude.
Right, no good. Like you definitely gave me an answer as to why they did it that way. But what I want you to try to do is maybe see if you can find a way to answer it while shitting on, like, cause I remember I heard someone say it once and it made me think, it's like, that is true. They were saying, even though you were saying, I can't remember who was arguing, it was one of you guys' arguments, and they were saying, they put you at this imaginary position in the center of this presupposed sphere with a radius value, whatever. And then they were saying, so if you shoot out an angle from that to the, let's say, by the time that angle goes from the gobstopper core, soft chewy core, until by the time it reaches the surface, it represents a position from there too. It's the same as if it was from the core, or if it was, but then if that is the case, if you do just deal with the angle from the surface and if ignore the fictitious position in the middle, well then you could use a plane now, couldn't you? Because pretty much you are treating your local position as a plane and a flat baseline of it. So I guess what I was trying to ask you to answer the question is in a way that, imagine you were them trying to sell your two-sphere model and the necessity for using a globe, which you did, but you didn't tell me why you would fail if you tried to create a
Oh,
plane model. Like,
so
why do
so
you
so like
need
so
it?
like
Why
why
can't
so
you just
why
use a
theirs is
plane?
mutually exclusive and we're better?
Right, right,
My bad. I apologize. I
right. That's what I
see.
was asking you to be a
So so
salesman.
this is actually something that I found with the Buddhist stuff on Tuesday. Is they not only introduced their model, based on astronomy, but along with that came their teachings of Newton's laws and
basically,
Ah,
they were saying that this is the true positions of the heavens, and the Buddhists were like, "Yo, what are you talking about? We only see the apparent positions because what we, this is an illusion. The true bodies are, in a different position, and they had their own model for that. So what? So the true selling point of it was making like turning the heavens into physicality, like applying like, oh, that's actually another rock, and we weighed it, and it weighs this much, like all
dynamics. You
those
got to sell the
all
dynamics with it.
the dynamics. Yes, sorry, I was not fully listening to what you
No,
were
I
asking,
didn't
but yeah.
ask the question clearly as I could the first time. But yeah, nah,
But
now I
yeah,
get it.
no, that's exactly it, and that's why Michelson Morley and relativity and all that stuff is so important, because it's all intertwined. Because in order to sell you a conceptual model based on a ratio of time, it's like you got to go hard, dude. So when they started taking their measurements, and it completely contradicted their conceptual model of the heavens. I mean, that's their claim to linking the celestial and terrestrial sphere models. Because other than that, it's based off of a fictitious observer.
Yeah, no, I get it. No, totally. That's it. I'm done with my question. My bad. I'm glad I got those questions answered.
I'm just wondering, is Kofi gonna bring the smoke now? I think he has some questions for you guys.
Yeah, let's get to the J factor.
Oh, well, real quick before we
Yeah,
move
no,
on,
I
to that
actually
one
had a
guy's
question
question
for
about the
Mike in
stars.
verbatim. I wanted to know how
Hold on, real quick.
he.
What's his name? Was trying to say something real quick before you ask Mike your question. What were you trying to say? My bad.
Yeah, I'm sorry. That guy that asked the question earlier, his question got overheard. Shane didn't hear him, and then he was talking about his own thing. But that guy's question about why are certain stars visible only at certain times a year or whatever, and that's just part of the sky moving. Like that's it doesn't have anything to do with the like ball curve. Those stars are out of your position now. Like the sky is oscillating. But that would be my answer. So anyway, I just wanted to answer that guy's question because it did get overshadowed a minute or for a minute. But anyway, go ahead, coffee whenever you're ready.
No, I basically want to ask Mike, how did he find that this refraction offset was equal to d squared over r2?
So that's a good question, and I was uh, I was reading Gigi Bennett's 1982, let me see, 1982 paper, I believe it was, where he was describing how he was consolidating the various refraction equations, and looking at his curve, I was beginning to realize that that curve is just compensating for the viewing angle, and the viewing angle in everything I'd read about theodolites, our globe Earth friends believe that the a terrestrial theodolite measurement is accurate, and it measures what they expect for globe Earth. But I was realizing that in Gigi Bennett's celestial refraction, the curve of the Earth was built into that measurement. And so I began looking into, well, does the same thing happen with terrestrial refraction? And the conclusion I came to is, yes, it does. Um, and and uh, that's when I first began mentioning the entire illusion of a globe Earth is entirely built into refraction, and it doesn't matter whether you're dealing with terrestrial refraction or celestial refraction. The curvature of the Earth is built into the refraction, and so it was essential to eliminate refraction from the measurement. And so that's what got me started on that.
Okay, is because it sounds like more of a self-realization. Is there anywhere outside yourself that this is corroborated, right? Any other observations that could entail this? Because when I looked at the graph and worked out some of it for myself, I seen that, and I may not be the best with it, but I seen that you had an 11th of a degree um that was unaccounted for. And I was like, so it doesn't match up 1 to 1, right? If there's still some missing. So how did you reconcile for the unaccounted?
Well, actually, what you brought up is specifically what tipped me off that this is where the globe is hiding. It's because the there's always a discrepancy in refraction adjustments. They have to account for pressure. They have to account for temperature. They have to account for um, the infrared transmission of the air. They have to correct for the wind speed. And I began realizing that every argument that where somebody is using something involving refraction to demonstrate that the Earth is a globe, what they're really doing is they're cherry picking their conditions to give them the answer they're looking for. And I did a bunch of calculations where I realized this every time. This is where the illusion of a globe is hiding, and that's why it was so important for me to find a way to eliminate refraction totally, and um, and then of course having a peak occluded star that cinches it. When the star's gone, refraction had nothing to do with this. That peak just intercepted the starlight.
Okay, so there's no other corroborated observation that matches this foreseen data.
There is nothing to corroborate the validity of refraction. Period. I've
Yeah.
read a lot of supposedly scientific papers about this, but you start reading this, and what you find is just it's people firmly believe refraction is real, and the Earth is a globe, and therefore, of course, the refraction follows the globe because it's a globe, and that's not it at all. No, it's refraction is a necessary evil for our globe Earth friends, but for the celestial theodolite, it's totally irrelevant.
Yeah. And real quick, coffee. I put a link to a spreadsheet, or Kat put a link to a spreadsheet in the chat, and it has the calculations for the, like, if you enter a distance and the elevation difference, it'll give you the calculation for a flat Earth prediction versus a globe, like, and then what the globe drop would be. And it also applies a celestial refraction coefficient to the difference. And you can see the comparison, like celestial refraction and terrestrial end up making the difference up every time, or it'll be over. It's actually over, but it compensates for it on the back end. So you can, to kind of quantify what Mike was saying with the relationship when he looked at the formulas. And I think I'm not sure if I went over this last time I was here, but when I started looking into the celestial refraction corrections and how they were derived, the input is the globe and the output is the globe. And the reason for that is because they're integrating real world measurements into their model, and then they just computate the curve fit for that to get what the value would have to be to multiply to that angle, so that it'll come out to be where the globe needs it to be with respect to 15 degrees per hour. So it's all computational based, and it's not based off
Yikes.
of anything real. It's just like where it has to be. And there's even I can give you some references where the authors of the paper even said themselves that they would like to see more experimental evidence to back up what they're computating, but unfortunately that's not, what they do.
You know, it's funny. I
It-
had my day
every-
actually started this morning with a interaction in a coffee shop in Manhattan where a lady gave me this book, Bernoulli's Fallacy, and it literally gets into this. It's really
Yo.
talking. I don't know if you're familiar with the word, but it's literally talking about how my day. This was like the first interaction I had this morning, like 7 in the morning, and it was about. It's really about when science took this turn toward pretty much using statistics and like empirical statistics to kind of like fucking lie to itself and just sell anything it wants to sell, and like it's like you have like a replica. What do you call is it a what's the word I'm looking for? A crisis to having a reproducibility. What is it?
60% of the people in this room are believing what you're saying right now, or whatever.
It was just a
Yep.
little, historic journey into when things took a turn toward that direction, and astronomy is kind of at the center of it.
Yeah,
Uh,
how far away is that light? How far away is that light? Yeah, a trillion light years. Yeah, okay.
Yeah, but what I was trying to point out is that Gigi Bennett's refraction doesn't account for the amount of dip in that 203 meters of curvature. That's what I was trying to point out. It doesn't account for all of it. There's still some left over. It's about 11th of a degree, which is about what, 6 arc minutes in a sense. So that's pretty big in sense of a celestial observation.
Well, and Bennett pointed
Yeah, I
out
was
in
talking
his
about
paper that
Pikes Peak.
yeah, Bennett pointed out in his paper that the reason he came up with his equation is because there were literally hundreds of different refraction equations, all having little deviations in the magnitude of what you're talking about, and many much worse than that. And so the refractions didn't agree, and he was trying to consolidate it into one equation everybody could use that would give better results. And his equation is by no means perfect. What I did notice is that his seems to be the equation that Stellarium is actually emulating. Um, when I plugged his equation into my spreadsheet in place of Stellarium's refraction, it was giving answers that I could not tell from Stellarium's answer. But the whole point of celestial theodolite is, since you can't trust refraction and it's constantly changing, let's eliminate it from the equation altogether.
So there's nothing here with any conclusive authority, right? There's nothing that it lacks conviction. If I could find the perfect words for it.
Oh, are you talking about how they derive the celestial refraction coefficients? I agree.
Gigi,
You're breaking up, Coffee. But are you still saying that uh, a star that you don't see still requires a refraction? Is that what you're still getting at?
okay, here's a
not a
question I asked Jesse the last time when you got. I was trying to get someone in the room to help out who was more familiar with the data set. But I was asking Jesse. I said, from my understanding, my question is: so if we, because I kept pointing out the data, the more like the manpower, the more data will bear this out clearer and clearer as time goes on. And my question was, is your understanding so far from looking at the data and your prediction that if we just had flat Earth, because they're accusing Jesse and John were accusing Mike of they were being a little bit more nefarious. They weren't saying it was a coincidence, but that he cherry picked indeed a range that could sort of match a flat Earth prediction and kind of get lucky. And that before, shorter than that range and longer than that range is going to fall apart pretty quickly in favor of the globe. And my question is, so if we just randomly went out and we did actual predictions, right? Could the globe use globe math and make predictions with, and let's say we completely shelved refraction entirely, we put refraction on the shelf and we just dealt with a geometric prediction. I would assume, in my opinion, that the flat earthers would always end up closer to the mark than the globe earthers in a bigger range of distances and peaks or whatever. And I was told that no, it would absolutely work in favor of the globe.
Yeah,
So,
real quick.
so
Uh,
I got a direct answer for that. Okay, so Kat and I got a C star and did random observations at random distances. We would drive around wherever we landed at a good spot. We would set up and see if we got occlusions. One of the distances we used was like 5.4 miles, and I forget our elevation or whatever, but that one was basically indistinguishable from the globe in terms of angular difference and all that. And then we did one from, I think it was 50.4 kilometers, or was it 40.5? I can't remember. It was in the 50s. I'll have to look at it in a second. But we did that one as well. That one was flat Earth. Now, if you want to get a globe Earth observation, and Jesse can confirm this, you have to do it at sea level because there's going to be enough and for far enough distance at an elevation low enough in terms of the peak, uh, so that the celestial refraction correction matches the expected globe drop.
So my question is ultimately, do you think that that range where you could get lucky and actual refractive conditions could help match, a geometric globe prediction? Do you think that
No,
so which
no,
sliver, who has the
no,
biggest
no,
sliver,
because
I guess?
no, because the second part of Mike's analysis, where we can backwards derive the elevation based off of the occlusion timing, the globe is off every time because and in addition to that, they're locked into their refracted angle, so they can never even have our angle. Like they literally need their own timing, and they're scrambling to try and find or trying to take ours or obfuscate it and make it seem like the methodology is invalid. It's like while simultaneously using it to uh, show emergences and occlusions based off of the same principles that we're doing. So, you know,
You know what's the crazy part, Alan? I accuse you guys of doing the exact same thing. That's the crazy shit. Like, I
so,
honestly do. You feel me?
okay.
Because at the end of the day, right? I mean, through Mike's works, he just proved it. You could use one refraction equation and another. You could use Gigi Bennett's, right? There's no conclusive authority to which formula you're using. So this shit could go either way. There's no
No,
bearing
no, no,
to
no.
any of this.
Whoa, whoa, whoa,
Like,
whoa. One second, one second,
without
one second.
without the J factor, like it's
Yo,
uh,
there's absolutely no J factor included in this. We're specifically talking in our analysis about backwards deriving the elevation angle from the time in which it was occluded to get what that would be in meters for the mountain. We're not J factoring anything at all. It's like what was stated at the beginning. The J factor is a supplementary analysis that you could do to clean up the data to make it more obvious. Because when you do it just based off of the occlusion timing and backwards deriving the elevation, it's the globe literally can't do it. And what you're mistaking about refraction is that the occlusion process is entirely physical. So or I'll have Kat put a link to the celestial theodolite Prezi where you can watch the videos and look at the slides. But what we showed is that a refracted object does not block refracted starlight. Taylor showed that with a knife and a cup of water. And then also Goose made a rig with a dowel where he showed that when you add a refractive medium between you and what you're observing, the starlight on the other side has to go down a little further before it's occluded. So there has to be the refraction, even with refraction, right? Even with any amount of refraction that you want to consider on your side, when that physical intersection happens, it's no longer visible. So you still require a different timing. Like that was you drew the completely wrong conclusion there on what I said.
nah. I think you missed. I think you misheard what I said. I wasn't trying to accuse you of applying the J factor to your measurements or cat's measurements. What I was saying that without it, right, it just falls back to which eyes you choose to look at this experiment or observation with. Globe eyes or flat eyes, because from what I'm seeing and the data that I'm getting, it falls either way without the obscurity of the J factor.
Yo, real
It
Oh,
quick from
falls
the
no,
either way.
top,
so
because
It
today's
just
my
it
first
just
so real
day.
it
quick,
just
real quick.
it just relies
Hold on.
on whether you want to account for curvature and refraction or not.
Yeah,
That's
real
literally all it falls down to.
Wait a minute, really quick,
no
guys, from the
no
top. Can somebody just from the top just tell me what the hell a J sounds cool as hell? I'm not sure what the J factor. My first time hearing it today was the story of the J factor.
the, yeah, go ahead. The J factor was
I
a
thought we was being
correction
anti-Semitic
that
for
was
a minute.
applied.
I'm glad somebody added that. Go ahead.
Yeah, so Mike was attempting to calibrate the celestial theodolite, right? So he came up with a method where you do an azimuth correction to get the what do you call it? So basically, like, you know, you're X distance away from the mountain, but when you go to the mountain, that because the longitude of the spherical coordinate system, it's going to be off a little bit. So what he was doing was correcting for when the azimuths align up to the mountain peak from when it's observed from the observer at X distance away, to be generous to the globe to make it fit the perfect globe correction. And that was the premise for applying that. And when you do that, it cleaned up all the data in that way. And, you know, people are calling it a fudge factor, et cetera. And that's fine. Like, we don't even have to use that part of the analysis, because the important part, as Coffee maybe didn't understand there, was when you backwards derive the elevation that based off of the occlusion time, it it's like the globe literally can't even agree with it, because you're based off of an apparent angle, and the mountain's angle, like the mountain's elevation is the mountain's elevation, so like you're off every time.
Yeah, that's my point. You could choose to you look at it with curvature drop or not.
What?
It's the same. It's exactly what I'm proving. I told you guys this shit earlier. Like, yeah, it helps perfect. It just proves what I've been saying this whole time, guys. It doesn't matter which, like, it doesn't matter without this J factor. It just depends what lens you look at it with. It literally does. Yeah, I know. I never said it was. I'm saying without it,
Yeah.
without it, because at the end of the day, right? Does the J factor change the timing or not?
Yeah, Coffee. When I'm talking about backwards deriving the elevation, that's not part of the J factor process. And your conclusion about looking at it from any perspective is, again, it doesn't make sense, because the elevation is the elevation of the mountain, and only one of the predictions matches the actual elevation, or is closer enough to what the actual elevation is. So, like the way when you're saying like,
Until you
yeah,
account for
so,
curvature
so,
drop,
so
because once you
dude,
account for
what?
curvature drop, it just comes right close to the globe prediction. So it just
No,
depends on what
coffee,
you account for.
coffee, coffee. Please don't interrupt me. And obviously, we accounted for curvature, bro. That's the premise. We're comparing the two. Like what you're saying right now is like, it's low key incoherent. Huge, yeah, huge mistake. You should go look at the data,
Yeah,
and
yeah, no,
then
I
hey,
think I think
hey,
I
coffee, coffee. While you're looking at
concluded
the
with
data, do me a
Jesse
favor.
on this for the
Look at
first
look.
time in
Oh, did you
Clubhouse.
now? That's fine.
You feel
Check
what I'm
this out.
saying?
Go to the spreadsheet. You feel what I'm saying? And look at the elevations for Jesse's
Well, I
equation,
checked the
and look at
spreadsheet.
ours.
All the
Oh, no
discrepancies
way.
line up to
So
curvature
you can
drop
see,
for
the
each
consistency.
observation,
So
whether he
Jesse
moves
changed
the
his
mountain peak
elevation
or
to try
not.
to make it match
I'm
what the
not
globe
bugging.
suggests.
It's in the
Hold
That's
on,
tight,
data.
yo,
bro.
one at a
Oh,
time,
that's
fellas.
so
Come on.
cool, bro. That's fucking tight. So you're saying that when you went to Jesse's spreadsheet and you saw his elevation adjustments, and you saw that we didn't do that at all, but you saw him J factoring his own data to make it fit, to make it give the appearance that it fits the globe better. You're saying that you are on board with that, and like I'm wrong? Like, bro, you're out of your
I'm
depth
talking
here, or
about
we're
the
gonna have to move
spreadsheet
on. Like, I don't think
provided
you
in
can
the
even look at it.
celestial update. My brother, the celestial theodolite update. I have all of them.
Then okay, so listen, go look at the elevation differences then, and go look at what the actual elevations of the mountains are. So like your conclusion is like erroneous. It doesn't even make sense. How could you draw the conclusion that you could look at it through any aspect of the data when only one data set it matches what the elevations of the mountains are? That doesn't. That's crazy, dude. Are
Bruh,
you
I
telling
said
me it's
that in the
definitely
first
a
10 minutes of, you can ask anybody in this room. This is what I said in the first 10 minutes of this presentation. When you first presented it in this room, I said that in 10 minutes. I just had to comb
And
through
it
the
was just
data
as
just to
wrong
confirm it.
then as it is now, bro. We've literally been trying to get you to understand you like the issue. I'm not trying to be rude, but if that's your conclusion that you're drawing, you don't understand the issue.
Is there any way that that you guys could like walk through any of
Yeah.
just to show
Yep.
where the discrepancies are, and then explain like why it's not a discrepancy?
Absolutely. If Kat, if you could put the Discord link to the Flat Earth Gang in there, you guys can follow along in the main chat to look at the images. Shane, if you want to go over some of the measurements that you posted and explain the graph and how it works, and I highly recommend. Let's see, can we put a link to? Do you have your Canva link also, so we could put that in the chat as well? Put the Canva in there. I highly recommend pulling one of these bad boys up so we could all go over it together, because being on the same page is going to be extremely important moving forward as the complexity of this conversation is about to increase tenfold.
Maybe
Now that is confirmed by Jesse Ruhiff and every other Glober. No other person disagrees with that as the globe prediction. So we've deduced the globe prediction and the flat Earth prediction. We have the observer over here in the corner has no way to deduce what angle that was at. All he knows is that he calculated it would be at 231. Now you go to your favorite nautical almanac or stellarium or whatever star position. You reference the time of the occlusion that you recorded with your chronometer over here. You do the math from the local sidereal time to get the true position, or you reference stellarium, whichever you want to do, and you find out that true position is actually 2 degrees 32 minutes 51 seconds at the exact time it was occluded. So you see the flat earth prediction of 2 degrees 31 minutes is spot on for this particular example, and for every example subsequently. And the final part is that now you construct a new triangle and you determine the height of that baseline because now you have a true angle, right? Our angle is 231, 2 degrees 31 minutes. The globe angle 2 degrees 17 minutes. So from there, you do some basic trig. You do say that same distance, 50,700 meters times the tangent of 2 degrees 31 minutes. So you do the inverse of what you started with, and you get that height, which is 2,226 meters, which equals, the exact height of Pikes Peak. If you do the globe equivalent, 50,700 kilometers times the tangent of 2 degrees 17 minutes, the locked in refracted globe angle, you get 2,025 meters, 200 meters off from the height of Pikes Peak. And that's the data that Mike graphed, the difference in the predicted height at the end. So there's no factor, there's nothing else applied. The only thing that you knew was the time of occlusion and that it was occluded, right? That's the only thing you do. So with those observations is how the whole process works. That's why nothing is relevant from the observer to wherever to get the other refraction. All we can deduce is our prediction with the math, and then we add in refraction and remove Earth curve. Now that's the basic structure for all 43 of these data points, and that's how each one of them unfolds.
Coffee.
And also, you should definitely look at the spreadsheet if you literally haven't seen it yet. That's crazy.
Thanks for the breakdown, Shane.
Awesome breakdown. And he said that he did see it, by the way. He said he had it.
Oh, make sure
There have
before
been
you
a lot
guys
of
get out of here.
spreadsheets, by the way, as well. So to be fair,
Before you guys
There
get
is.
out of here, I had a $200 bet with John that I suspect Jesse was capping about. I didn't really, I'll pay John off if he's right, but I just want to make sure I get somebody who's familiar with the data and Jesse's simulation. Because I remember, I remember actually, was Alan parking on Jesse one time about his simulation applying the refractive corrections to flat Earth angles, and it seemed like Jesse was kind of conceding that as much. He was saying he did it because it didn't matter, and you were challenging him to just so then do it with the globe. And then Jesse, that was all I was pretty much betting that that's indeed what Jesse conceded to. And John said no, that would be a really big problem if Jesse did that, and Jesse said he
So
didn't do that. So
here's the
Did Mike
thing.
leave? Or my Mike still here?
He's still
nice
here.
here.
Jesse did go on to say that he later, fixed it or whatever. But the thing is, though, when you're doing celestial navigation, you're not out there making globe Earth adjustments
globe
to whatever the
correction,
thing is.
right?
You're just doing a raw flat. You're just doing your raw trig, assuming that the tangent to the horizon is on a sphere. So so in practical navigation, like literally when just adding that correction, it makes it come out to be what it needs to be to keep the star coplanar to maintain the 15 degree per hour relationship that they need
Right.
related to a position on the ground. So thanks to John for agreeing that is a problem. That's why we are questioning these celestial refraction corrections, right? That's why we're testing their conceptual model using this, because if you try to reference it internally with the optical position, it's going to be internally consistent.
Hey, Dr. Mike, are you're available for a question? Just kind of want you to elaborate on
Yes, I
something
am.
real quick. Awesome.
Nope, go ahead.
So what inspired you to make the J
It's
value and
accurate,
its
and
name
no
in
one
the
did.
first place?
Well, it's named in honor of Jesse, actually. Um, he gave me the idea when he suggested that we get our distances from the NOAA website. I had been using a website called Movable
Movable
Types.
types. Yeah.
Yeah, and he said that wasn't as accurate, and no one did a much better job. So I took his suggestion, I tried it, and with the movable types, you're lucky if you get within 10 meters, and I'd swear a lot of times they round it off to the nearest 50 meters, but whereas NOAA gives you 4 decimal places, so it gets you down to a tenth of a millimeter. So I started switching data over to NOAA, and then when I saw how much that cleaned up the data, that's when I realized, well, the bearings are a little off. So what stellarium is telling us the bearings are for these stars is not quite right. And so I added, and I realized that using the right ascension and declination equation that converts to azimuth and elevation, just by adjusting the timing of that, I could um, uh, shift the heading a little bit to align it with where it belonged. And after I did that to a few of them, that's when I discovered that I can make the globe Earth prediction without refraction correction. I can make that perfect. And when I make that perfect, that makes everything else perfect. So it drastically cleans up the data, and you don't really need that because you just take raw data and you can clearly see that the flat Earth angles are closest to no deviation, and the globe Earth angles are pretty far off. But when you add the J factor, it makes the lines so clean. It removes all doubt that the flat Earth prediction is virtually on top of the zero deviation line, and the globe Earth prediction without refraction is way below the zero deviation line. The globe Earth prediction with refraction is generally above it, occasionally for really distant peaks. Like we have North Peak, which is 82 miles away. That one is way below, but in general, with refraction, the globe Earth estimates are um, uh, well above zero deviation.
Got you. So it's just a way for you to clean up the data by changing what was it, the bearings that you initially had from movable types to something more accurate to NOAA. That cleaned it up pretty nice. And then you also wanted to fix the right ascension and declination conversion to alt as well. So there's like kind of a two-parter thing.
So you're close. Um, it started out being just a bearing correction, and it was a bearing correction using timing, little plus or minus um, time offsets from that would just add or subtract from the observed time until the heading lined up. Um, but it was a way of using time to um, fine adjust the conversion from right ascension to declination to as and L. And it was only the as that I really cared about because some of the azimuths coming from stellarium were not quite right. And then modern versions of the spreadsheet actually have the equivalent of stellarium built right into the spreadsheet. So it's a much more automated process than it used to be. But it was all about fixing little deviations that were you could look at the data and tell that that was not the right bearing, and so it started out being a way to correct the bearing, but um, it unexpectedly cleaned up absolutely everything, globe Earth and flat Earth angles. And so it's just a convenience, and the spreadsheets allow you to turn that on and off, so you can choose whether you want that or you want to see raw data. You get the same results either way. Is this with the J factor, things are noticeably much cleaner.
All
I
right,
actually
again.
have a
So
I
I had a
actually have
question.
a question for Coffee
All
real
right, all right.
quick. Are you sure that I asked him earlier? Are you sure that you wasn't misunderstanding, or you misunderstood what the J factor was, and because he said that this is where the J factor was where the fudging happened. I don't really want to put words into your mouth, Coffee. You could say it yourself,
No,
but
you're good. He
this
got that from Jesse. Jesse kind of like throws words around like fudge factor for no reason, just to kind of
Sweet.
poison the well. It's
Yeah, he
kind of
just
retarded.
aggressively lies about it all the time to try and make it sound the
Yeah,
worst.
he's a deceiver, dude.
Yeah, the
amazing.
first time I came here, I kind of felt bad for Jesse because he seemed so mild
Don't.
mannered, and I felt
That's
bad
his
like I
stick.
treated him. And
It's
then the first time I actually had an interaction with him, in the first few seconds, I had to check him like, bro, just fucking like, why you talking to me like that? Like we've never. Why do you think you get to talk to me like that? Like he just started immediately. Like, if you know anything about basic science, I'm like, bro, you never had a fucking conversation before. Like, let's not get disrespectful right out the gate.
Yeah.
Yeah,
So now,
Jesse, since you're in here, you're gonna stop calling it
no,
the fudge factor.
nope, don't care. Don't care what Jesse says. He's not allowed to participate anymore. I have to lying aggressively about everything all the time. He just really goes to all the other groups and tells whatever aggressive lies he gets away with, regardless of what we try to tell him or what we try to learn him. But whatever.
Yeah, he came in so coy and mild mannered, it seemed like, and then quickly. But my question is, all right, so let's say we put refraction fully on the shelf. Nobody touches refraction, just dealing with straight sphere versus plane. We start with 5 mile mountain, then we go to 10 mile, and we keep going in, let's say, 5 mile increments without considering refraction, just making predictions of angles and timing coincidences or whatever. And my understanding is what the data's been bearing out so far is that flat Earth is a far more reliable assumption that'll get you closer to being able to make a prediction of the timing, and that starting from five going all the way out, both will fall apart eventually, slowly, but that the globe will fall apart a lot faster. Is that correct, or that the globe would never really even get it? Will never be as close as the flat Earth without with no consideration of refraction.
Well, I think for that ratio to even work, like you need a
So
flat baseline. It's crazy.
so the only way to make, or like they're always going to be off because they're locked into the optical refracted angle, and their geometric angle is never high enough to meet the elevation difference. So that's why Mike's second analysis that he added when it was backwards deriving the elevation of what did the occluding based off of the occlusion angle. Like when you do that, you get the actual elevation of the mountain when you add that elevation plus the actual elevation with respect to sea level. And ours matches more closely to what the actual elevation is, and the only way that could happen is if the Earth isn't a globe.
And Coffee, can you clarify something for me? Was the silver bullet the nadir or was it the J factor? Because I remember Riot talking about the nadir not being taken into account. Am
Oh,
I wrong?
the nadir. So nobody takes into account the nadir when you're in negative coordinate systems. We were kind of touching on this earlier. The when you're using your hemisphere, when you're using the celestial sphere, the only part that you're using for to get your latitude and longitude is the stars that you see, and that's going to be marked in positive values. When things go out of your vision due to either Earth curvature or just circling out of your field of vision, you plot them as a negative function, and whether however you want to display that is irrelevant. So there's nothing if that's the silver bullet, you can defer to the stellaria map, and you can enable the globe projection of it, where it's I think it's called the equatorial projection or something like that, or you could look at it as the azimuthal projection, and that one makes the stars circle above you. The other one makes them go beneath your feet. They're literally the same thing. Like they're kinematically equivalent. Like it's built into Stellarium.
Yeah, hemisphere and
Dude,
spherical are identical.
the silver bullet, the fudge factor, these sly ass tactical maneuvers from these guys. It's fucking pathetic, dude.
I know you guys pissed off Coffee because he left.
I got a
No,
quick question about
yes, sir.
refraction, if I may. Um, so
Absolutely.
this is really for my comprehension, but so I understand the method was devised to eliminate refraction, and so we're taking angles to mountain peaks, we're recording the occult timings, and we're comparing them to each model. So my question is refraction actually completely eliminated from the equation, or is there still a little refraction being accounted for in the flat Earth computations? I just don't quite understand that.
No refraction in flat Earth. We do account for it in the globe though perfectly with Gigi Bennett.
Gotcha.
That's
Okay.
the Yeah, that's the point of using an occlusion timing, right? It's like when
Right.
you can't see it.
I feel like I've heard Alan say
No,
things where
no,
there's
you're
a
good.
little negligible refraction still included, but I just wasn't
Yeah,
sure about that.
yeah. So when there's refraction between the star and the mountain peak, right? Like there's going to be some of that, but it's not going
Okay,
to be
I got you. Yeah.
but it's not going to be to the entire tune of the exact ratio of the missing difference,
Right.
because
Gotcha.
because
Gotcha.
because
Gotcha. The
oh,
terrestrial refraction. Yeah.
Right. A star is just a little point source of light. If you look at it through a telescope, it's about, or like the recording devices that we're using for this, it's about an arc minute or an arc minute and a half in size. Very, very small. And
It's not
so,
gonna raise it
so,
22
so,
arc
so,
minutes up or whatever.
yeah,
Gotcha. Okay, that
right.
makes a lot of sense. I totally understand now.
Yeah, yep, yep. Awesome. So it's like even with it, that's why we don't care, because even with it, they still need a different timing. And I can get you a link to, I think it was Celestial Theodolite update number 10. Our good buddy Goose built a rig where he demonstrates this, where he shows what the refractive index or what the refractive angle is with no refraction media or refractive medium between the light source and the observer, and then when he added a medium, the occlusion timing does change. So they literally can't have our
Gotcha.
angle.
Yeah,
The
I saw
intersection
that.
has to be
I just
physical.
it takes a few times to hit me in the head for me to get
Oh,
this.
no worries. No worries. Awesome.
You know,
Awesome that you saw it. I'll have Pat throw a link in there anyway for anyone else. But awesome.
I don't know if anyone dropped this link already, but what would probably be good to show him and also to demonstrate for anybody is those I think it was what's her name Taylor had showed like the little like water in a beaker and showing that the refracted
The
image can
knife.
a
Yeah.
lot.
Yeah, if you go to this Canva link, it has everything we've ever made, a whole bunch of new slides in that video, and a bunch of everything.
Dope,
Wait,
dope.
Cat, you're mod now, right? Can you poke? You guys know how to do that, or tell
Oh yeah,
Cat to
yeah. I
do
made
that?
you a podcast so you could pin. This is like pinned link. You just gotta click that on the top and it lets you pin a link on the top of the room. Whatever we're talking about at the time, you can pin it so everyone can see it. I'll
Kind
do
of
it
just
too.
kind of crowding the chat with dog
I'm
water
not
arguments.
sure how to pin it.
I got
Once
you.
I
Let me see.
post a link, how do I pin it?
About to figure it out right now. I'll tell you. So you click the three dots at the top of the page, and then you should pop. It should pop up, and it says, you see a little drop down. It says pinned link, and once you click that, it'll tell you to enter the URL. I'm doing it right now.
Pin link. Gotcha.
I just did it. I just put it up there for you,
Perfect.
or
Oh, it's
whatever you want
over,
to
you
change it.
guys. It's over. She's about to pin some links. You guys can't have any excuses.
There it is, right there.
Nah,
Can you just
I
do
felt a little
one
bit
pin
like,
link at a time, or can you pin
yeah,
more?
yeah, yeah, one at a time, man.
One at a
Feel
time.
like y'all
Okay.
low key shitting on us
Place
on
the last
Clubhouse.
one.
I heard, I think it was Alan called us the Clubhouse permanent. I felt like it was kind of like a pejorative. I don't know how to feel about. You mean we calling Clubhouse permanent?
Clubhouse permanent.
There was some slight social shame there to get you to go to Discord.
Yeah,
Dude, you
screen
guys,
share.
The Clubhouse
you guys
permanent. So
need to get on Discord, dude.
Like
Like,
screen share
you
is pivotal,
nah, for
dude.
sure.
Your whole experience going crazy.
screen share, just archives, just immediate access to different voice channels, and it's crazy how
Like
you guys are not
TikTok, like
there.
it's TikTok is too like I guess that's where everything
Oh
is
man,
just too fuck. I'm a boomer. It's a little too noisy for me. I catch the TikTok shit a week later when it lands on Instagram. Like I catch you guys
no, that's all
Tik
discourse and shit
garbage.
on
TikTok
YouTube.
sucks. Yeah, no, I agree with you there.
I just feel like I catch all the good content on YouTube anyway. Like after you guys stream it on.
Yeah, but I mean, imagine being there. It's like live, and then like actually being able to interact. I don't know. You guys got to get on Discord, dude. It's time. It's time.
Yeah, and my
Clubhouse,
Yeah,
you were
bad.
cool. You were cool and all, but like, it's time.
Yeah,
yeah.
my bad. I kind of races towards Shane's towards Shane's shit because I always go to Space Order to catch up on anything that you guys drop, and I know Shane is always streaming too. My bad, Shane. I'm gonna try to give you some views
That is
too. My bad.
racist, definitely. Yeah.
Yeah, it's like by default, bro. I was just typing Space Audits, you know what I'm saying, to check out whatever I missed.
That's what I do too.
So you're guilty like me.
I think I have Space Audits bookmarked on my browser tab and not my own channel because I can just go to like, YouTube or whatever and go to your account. Yo,
Damn. So any more contentions? No, nobody.
the simplification really helps because then it kind of breaks down the understanding of what we're talking about and the simplest components, especially when people try to add layers to it and things that aren't necessary, right?
Well, Shane, what was some of the stuff we were talking about earlier in regards to the difference in angle predictions with 11 arc minutes versus 22 arc minutes? Because that's a hugely important concept to go over because we're dealing with the geometric versus the optical, and like how that math relates, and how the missing 11 is already in there. They're adding it back with the refraction.
Yeah. Yeah, I think Mike went over that really well. But essentially, it's all the discrepancy over the really small angles have an accounted for portion of geometric earth drop that's technically for the geometric position would account for it twice, and for the optic position it would only be once. So it comes out like optically like 11 arc minutes and geometrically 22 arc minutes. But the way that it balances out is that we add one and subtract the other, right? Because we do the drop over distance, we subtract that from the flat, and then we add in celestial refraction. So double drop over distance accounts itself. It equals the exact same prediction as Jesse was contending, but the difference is like when would you apply one or the other? I think, right? Because if you approximate it, right here. So celestial refraction lifts it back up, but the double dip actually creates like that illusion of curvature. So like the actual 22 arc minutes full tilt uncorrected dip is what you get for geometric, and it produces the exact same offset of 11 arc minutes tilt for the atmosphere on in stellarium. So that's how we match our predictions, right? Is that our prediction with refraction on matches the glow prediction and all of these predictions. And when you account for it that way, it matches even the small angles that Jesse tries to bring up below a half a degree. D3, I think you're hot, Mike.
Did you make that coffee?
D3, you're definitely hot, Mike.
Yeah, man. I was, we were talking a little bit about the meta earlier, and because someone's kind of asking like the why question. I'm just like, man, like if you give these people that fucking magic wand, if you give them that gaslighting ability, man, that blank check to just tell, like as I'm sitting here talking right now, I'm literally looking at a star, and I'm just imagining a guy next to me being able to tell me, yeah, you see it there, but it's where I say it is. Like, look over here at this paper. Like, man, it's a lot of power to give somebody, man. Like the implications here, it's far reaching, man.
Yeah, that's what the Buddhist monks were fighting against, and they lost the battle even with a working conceptual model to show the equivalence between the two. So it's going to be a rough battle ahead, boys, but the, onward we go. They're going to do what they're going to do.
They're running out of stuff, though, man. They're running out of arguments, I feel like.
Well, if I just say silver bullet and fudge factor a bunch, I'm sure I'll get people like Teddy over here to just chant that, and that'll be enough. I can make a YouTube out of that.
We need a flatter. Yo, but something off topic. Stone. When is the thing that you're gonna do on? Isn't it on Glowbusters? When is that?
Hey guys, yeah. As a matter of fact, it will be. I'm all lined up for this Sunday afternoon. Absolutely.
Sunday afternoon. What time? Like well, I guess Eastern.
I think it's 3 Eastern.
3
And
Eastern, yes, sir.
yeah, and we're gonna do a recap of the Shadow Sets deal. It's gonna be good. Yeah, man.
Nice.
I love the
Yeah, I feel like
Shadow
it's a
Sets
really
presence.
slept on one. The Cell Theo's been taking up all, has been all the rage, but the Shadow says I'm looking for some more, some rebuttals and some more, action on that side of things. I haven't really heard too many.
I'd like to see some stuff on our side as well. I'd like to see some replication. I'd like to see some of you guys actually duplicate what I did and show me some data. You know what I mean? That's what's really important here. Not necessarily the objections that we're going to defeat. Extra,
Good point.
reconfirming data. That's what we need.
As Stone likes to say, more data in a cryptic voice.
It's actually get the data. That's my mantra.
But obviously, you guys didn't take into account the three different types of what is it? Uh,
Globies?
Twilight or
what
whatever.
what was it?
There's
3 different
7
types of
different
globies?
Twilights.
The Twilights, the different types of Twilights.
Oh,
Yes, yeah,
What was
right.
the
there it
All
is.
the
The
different
Twilight.
yeah?
Twilights. Right.
What was
Right.
the type of Twilight? What's the called?
You mean all the shit that happens after the fact? We need a bunch of that for sure.
Well, man, I won't lie, man. It's like there's a lot of bold refraction claims, but tops for me, man, is like the Canada and the idea, like when you see the sun on the horizon, that it's not there, that it's gone already, and you're like, and so like with Canada, like when I think about Canada, what they're saying is the entire image. I mean all of the ambient light, because all you're seeing is the silhouette of Canada
Dude, and the
and
shadow of the mountain hitting the
so
ground.
so,
How's
but
that
all
possible?
of that has to be around the horizon, right? All of it. The half a degree sun. I mean, the sun, whatever. The backlight, the cloud. That entire image has to all be not there, right? Am I bugging? Doesn't that have to be the
Yes,
claim that the sun, the mountain,
Have you seen the
the
video?
the
Dude,
it's two
it
types
literally,
of refraction,
Doesn't
dude. It's
Taylor's
crazy.
light light experiment with the knife and the laser also prove that the sun would be occulted, so it shouldn't even be refracting?
Exactly.
right?
that is the overarching implication here with the occlusions being physical.
Wow.
How could there be this big a disconnect? How could they not see that?
Yo, religious belief,
So
bro.
I think
It's
that they do see
desperation.
it,
It's
and then
desperation.
they like intentionally spend time and energy and plan to obfuscate, hide, and misdirect from that, which is my
Dude, we
argument.
could ask that question about quantum mechanics, about everything
Right.
Einstein laid down. We could lay that on string theory. We could ask that question all day long.
I think string theory is pretty much out now.
Hey, where did the dude go that was here earlier, man? I told him not to miss this, bro. The dude that said that a flash drive that was full was
Data.
going to
Oh,
weigh
fucking
it was
Oh
going to
John.
yeah.
weigh more than a
Oh,
Data. He said
that was
data is what
crazy,
he said.
man.
He
The
said data
data
is
has
is physical.
mass. Has
It's math.
mass. So like a full hard drive is gonna have it's gonna weigh more than an empty one, like the data.
You guys ever heard that before?
He's trying to assert that digital ones weigh more than digital zeros.
Yes, yes, that's exactly.
What's his unit of measurement?
Yo, I asked him. I said, man, how many zeros after the decimal? It's gonna be a lot of zeros. And we just don't have tools sensitive to measure it. I'm like, so bro, what the fuck kind of stuff you talking about? Bro? Like, why do you think that's real?
Mm-mm-mm.
I'm like, by
Hey,
that
real.
virtue, as I walk down the street and hear music, I'm gaining weight, bro. Because like I'm taking new information in. Like,
Real quick though, before does anyone else have any questions for Dr. Mike before he's got to get back to the dogs, or any questions?
oh, did you guys get any international? I remember there was some Czech boys, but you guys any international
I have a question.
observations?
It's
Go ahead,
not
D3.
about what he's doing though. It's something that I'm trying to kind of put together myself. Do you think we could use the gravimetric data that they take to produce the geoid? Originally, it doesn't have shape. Do you think we could take that and use that as a straight baseline?
Hmm.
The Earth's equipotential gravity-dependent directional field? No, I don't think so, dude. That's a made
Isn't
up.
a
It's
geoid
a made up intermediate
based
model.
on elevation differences?
Well, let's say when
No,
topography
no.
kind
So
of
so the
planes and
way
that.
so the way it is they we get gravimetric data on foot via planes, right? But gravimetric data is essentially just the intensity of the downward vector, right? Um, and so it doesn't have it initially. It doesn't have heights. There's no heights on the geoid. It's just considered an equipotential surface. So if they can use it, why can't we use it? If they can, so what they're doing is they're connecting that with the deflection of the vertical to an ellipsoid model. Why can't we have
Right, right.
why can't we connect it to a bar model? Why can't we start building a model that way? That's how they built their model.
It's a
Yo, were you
good
the one who
question,
came
dude.
in and spoke about sea level, like the datum, like the sea level?
Yeah, I went through all of that as well, and
Uh,
that's what got me to this, right?
I actually thought of that earlier. It's funny you popped in here.
Yo, D3, I'm down, bro. I'm bored. I'll help you out.
All right, yeah, because I mean, if you look at the geoids, like I said, man, they take the data. The data doesn't have shape originally. It doesn't have shape until they tie it to the ellipsoid. But we could use the same data; it's already there. We could use that and tie it to like something that's more like a rectangle, I suppose.
Dude, I highly doubt it, man. There's very, very few experiences where I found unadulterated data in any aspect, from GPS to anisotropic light to
Hmm.
Satnac to Michelson Morley to everything that we found is like pre-globed, right? And it's if you look it
Right.
up, so I can't imagine that this is just sitting out there with no reference to like free to prove no curve. In other words, right?
And
I
don't get
doubt
me
So,
it.
so you
started
mean
on what happened
you
to
mean it'll
Miller's
be hard to
data.
get the data that's not you? It would hard to get the raw data, right?
Well, you're saying that it's not related to anything, and I'm just saying I don't know. I feel like somewhere, somehow, it probably is. Otherwise, they wouldn't let you have it. But we should
Oh no,
definitely, we should
it
definitely
definitely
try
is.
it.
Braided back in.
Initially, it's not. Initially, like you could get a gravimeter right now and just walk around and take gravimetric data.
Maybe
That's
maybe that's the part I
essentially
don't
what they
get
do.
then, probably, because I don't
That's
really.
essentially what they do. Then they take that and they tie it to that ellipsoid model using deflections of
Yeah,
vertical.
yeah, that part I'm really familiar with, and then the geoid itself. But I didn't know that like you can go take a gravimeter and just take readings around of the which measuring what how hard 9.8 meters a second
Yeah,
is in your area. Is that really what it's doing?
that's how they're doing it.
All right, so then that just
It says like you guys look at the NOAA website. It says it right in there how they even give the equations about how they're doing it.
then what?
No,
Well, why is the geoid always represented as that lumpy sphere if it has no shape? Then
because they tie it to
oh, that's an
the
ellipsoid
ellipsoid.
tied geoid, so there is no
Yeah,
unadulterated geoid picture.
and there's no
Okay.
exactly, and there's no heights initially. The heights don't come in until they tie it to the geoid because I mean to the ellipsoid because
Right.
you need the ellipsoid to do the orthometric heights.
Yeah, H plus N plus whatever.
Right, right. Why can't we just jack it? All the data's there if we can get the
Hey,
raw.
Well, it
here's a
turns out
question:
we
what
already own it.
ellipsoid would you use? Oh, my bad.
It, sorry, D3, it turns out we already own it because their model is based off of apparent positions to stars
To the
and using
stars,
it
right?
to tie it all to time. So
But can't we
we
build a
already
model?
own it. It's already ours.
It's like that Spider-Man meme where they're like pointing at each other. Like,
Okay.
I love that meme.
Well, yeah, I mean, Alan, you said it before. It's like if they can use a fictitious observer, why can't we?
Yeah,
Yeah,
if you
we just
use a fictitious lad, then all mutual exclusivity is now off the table.
ah.
Exactly.
Well, that's why I was asking about the baseline because if we could use the gravity as a base, if we use the gravity data as a baseline, then we can use it to measure sea level against and all of the land-based benchmarks that they're deriving sea level from that they're that they initially get the sea level against when they're over the 19-year period.
If you do it, can you rename gravity and not use gravity?
Yeah, we would name it some other shit, man. I don't
Coulombs.
know. We'd come up with something.
Yeah,
We could do
Jamal.
like the kings of old and have a competition.
Yeah,
Right.
Jamal actually had something clever earlier. We discovered the Beatron.
The Beatron.
oh, the fucking Beatron, that was hilarious earlier. Yeah, this guy was like talking. I said, "So, man, by
That
this
was hilarious.
virtue, right? I can, I can reify decibels and make it a thing. Like I can give it a mass, and I can discover it and then take a picture of it. You know what I mean? It was like, why not?
Bro, that shit sounds heavy. Just
Nah, I
kidding.
say you might have sent me on my fucking path to go like get a Nobel Prize. Fuck it. I'm gonna take a picture of a decibel and like,
That was a bad joke. I said that sounds heavy. Yep.
oh yeah, I missed it. My bad.
I'm gonna shut up now.
Sounds heavy now. It's good. I missed.
All right. Let's restate it again. D3, I'll help you with your project. That was one question answered. Anybody confused in like any of the basics or like how could they reproduce it for themselves? Getting a C star in a watch or whatever.
Just
Yeah, I want.
know,
All right,
uh,
go ahead. My bad.
tomorrow
Oh,
coffee
coffee's back. There he is.
is back. All right, go ahead, coffee.
Yeah,
What you?
I wanted to ask Shane a question about his breakdown earlier, right before because my phone died. Where did you get the 7 arc minutes to add to the glow prediction?
What's 7 arc minutes, dude? There's no 7.
You said it was two. The glow prediction was 217, if I'm
Yep.
correct, and then you added refraction, which made it 224.
No. Now the final output
So
globe is 217.
yeah, so where did you get the 224?
What do you
Because I
mean?
could have sworn you said you added refraction to that to put the glow prediction at actually
So
224.
no. The globe prediction has always been at 2 degrees 17 arc minutes, but the way we get that is from the flat Earth prediction baseline. So we start with 2 degrees 31 minutes. We subtract the drop over distance, which is 27 minutes ish, 22 seconds, and then we add in celestial refraction at 15 minutes, and that is how you get back to 2 degrees 17 minutes, and that agrees precisely with Jesse's spreadsheet as well. So that's how we do it for every single observation.
Yeah,
He
am
didn't
I
add.
bugging? From the
If you
breakdown that I heard, he said that the 224 is what didn't match. Am
you
I
might be,
bugging?
There's no
yeah, you might
224.
be bugging.
I don't know what that
Yeah.
means.
If there was no refraction, it'd be 204. It'd be two. Yeah.
All right, so then my point still stands.
No,
This shit just depends on whether you
Yeah.
add in curvature or not. I think that I landed my point earlier. That's cool. I just wanted to make
No,
sure that point was landed.
no, man.
no, you didn't land a point.
I don't
Yeah,
think I
you,
don't
you're.
think you're understanding it. Every time the occlusion happens, it matches arctan rise over run. Period. Period.
Airball.
If that was your
Yeah,
prediction, you would be
without
right.
curvature drop. That's the point.
Well,
You feel
no.
me? You added
In
refraction to the
reality,
glow prediction earlier, which skewed it, but I think it just at the end of the day it just matters to the curvature drop, right?
added
No, we're
refraction to
comparing two different timings, bro. We're accounting for globe curvature. We're comparing two different things.
Yeah,
Jesse's
trying to
And
steal
prediction.
man,
Yeah, is
trying
we're
to steal
also
even
man the glow prediction, bro. Like, what are you talking about?
what
Are
the
you applying it to the initial observation? The timing of the observation. Are you applying it to that azimuthal height?
the timing is the timing, bro. Timing
The-
corresponds to angle in the globe model.
Yes, obviously that's the independent variable in all this, right? We're not changing that, right? My point is, did you account for where the point of the star that's occluded by the mountain peak, right? The actual azimuthal height of that mountain peak, did you account for curvature? That's the point.
for the globe. Yeah,
Obviously.
For the initial observation. Because
What is
that's the
that?
question
What
here.
does that
Which
mean?
The
method
fuck are you
aligns
talking
up
about?
to the observation?
Bro, what
So
is that?
I don't really
There's
understand the question.
there's just a recording of a star, and then all of a sudden the star's not there, and we know what time it is. I have no idea what you're saying, bro.
Like, what
Like
don't you
at
get
this point,
about
I
the
think you're just
setup?
trolling.
bro, the stars occluded at a specific timing. That's your independent variable, right?
wait, are you gonna
Yeah, there's
What
predict a different
constitutes your
time?
dependent variables, right, is the azimuthal height given each model and correspondence of what variables you're considering, whether it's curvature drop, refraction. That's what makes the changes the heights and the dependent variables.
What is
Am I
Bro,
bugging here?
what is an
you
azimuthal
said,
height?
hold on a second. You said that you had the spreadsheets. The answer to your question is the spreadsheets. Uh, what you're like, just give
He's just
another
lying
question.
again. He didn't
Like
look
you're
at the
literally.
spreadsheets,
No.
man.
He's only listened to Jesse. This is very unbearable.
Should I post it in my screenshot? I could post it right in my PTR.
So
I have it. I got numerous of them.
You know we're accounting for all three and comparing the timing difference. Like so,
It's
like
the
your
timing
question is
difference.
incoherent. That's just
Yes,
stop,
and
bro.
that's my point. Your discrepancy every time adds up to curvature drop. That's
there's
that's
no
that's the point that I'm trying to point out here.
That's retarded.
Well, the discrepancy is the there's no the timing doesn't correspond to a time that would correspond to curvature drop.
you're saying we're
That's your
ruining it
problem.
by adding curvature drop, and it's like, yeah,
That's your
I mean
problem.
it does,
Yo,
but
Bobby, real quick, do you realize that your problem is your problem, not ours, right? Did you? Oh my God! Did you, coffee? Did you not? Do you not know what the celestial like? Do you know what we're doing here?
That's what it's. Earlier I asked. It seemed like, bro, do you understand that that's really the whole punchline? It's like that you're taking our punchline and acting like it's yours. To me, it seems like what this is showing is that you need to use celestial refraction to call it globe, Earth curving, and
No, we need curvature drop, bro, to call it globe. That's the point that I'm trying to point out here. I
the
think
Not enough. That's
the
everybody
always wrong.
methodology is attempting to
and
decide,
and it
right? Which
makes
one is it?
it just turns the observation into which model lens that you want to look through it to.
No, coffee.
That's all it
When
does
No,
when
because
you
not
you
at
when
have
you
all.
to
when
apply
you
the variables to the observation.
when you put on
The
curvature drop,
observation itself, you all gotta apply the variables given the distance. Yeah, you're observing it
Hold on,
from.
hold on.
when you put
Shane
on
was about to say it.
when you put on curvature drop, dude, it moves all of the glow predictions above the flat Earth and above the correct. And when you put on just refraction, it does the opposite, right? That's why he graphs all three of them. They're all accounted for, and it doesn't. Just saying that it doesn't matter which one is ridiculous because it specifically always aligns with the flat Earth. The
What would
the
be the point of doing
the
this?
flagship example is 2 degrees 31 minutes versus 2 degrees 17 minutes. Your boy Jesse agrees with that prediction. He says that just because this one matches flat Earth, yada yada yada. Okay,
Yes, that's
so
the glow
that's
prediction. When you
it.
subtract,
Doesn't match
right,
the
the
globe
given
prediction. The
curvature
globe
drop
prediction is
from the
wrong here. I don't understand how you don't get that. The globe prediction fails
every
Mike's
time,
speech.
every observation in your graph, once you apply the curvature drop, given the distance, translate it to degrees, translate that to arc minutes, it gets closer to the globe prediction.
That's wrong. That's exactly
Shane,
wrong what
let
you
me
just
How?
said.
How?
One
How?
second. It doesn't. And in addition to when the angles are closer to the horizon, it gets harder to distinguish. So what Mike's and other analysis that he added was backwards deriving the elevation based off of the occlusion timing. So with that, we can definitively know which model is closer to the prediction because the globe makes a lower elevation prediction because it relative to that observer, the globe predicts that it's lower in the horizon. So the star has more time to be visible. So it's going to occlude later.
Yes, once you start backwards deriving the occlusion timing, you feel me? That's when you start the muddy waters because it doesn't matter at that point which model you look at it through, which lens, because it
That's
depends on what variables you add to the
That's retarded,
observation.
bro.
just empty rhetoric, dude. Just literally empty rhetoric.
Where Mike at?
Empty rhetoric, dude. That's all that is. This is like coffee. You really revealed yourself, bro. I always giving you the benefit of the doubt. What you're doing right now is absurd. We're comparing three different models with mutually exclusive timings. The timings correspond to an angle. When we backwards derive what the elevation is to correspond to that, we get an elevation that's
Yes,
closer to
once you
the plateau.
backwards derive the elevation, right?
Interrupt
It
me, man.
just it
That's a
just depends on what variables you're including when you
the
backwards
only
derive
variable
it.
is
Coffee,
That's all it
don't
does.
don't repeat yourself, bro. Hold on.
the only
Let
Especially
Alan
variable
finish his point. Let Alan
is
finish the whole point, please.
Right.
time of occlusion. You
Okay.
have empty rhetoric, man. That's stop doing that. That's crazy. You're not even saying anything.
You know how he's able to backwards derive it, dude? Because he has a
By
timing.
taking our timing. That's it. You're
Oh,
taking
your
our
timing
timing
now?
backwards, deriving it to the flat Earth model.
Wait,
That's
who
it.
made the observation?
It's the actual
They
timing,
trying to
bro.
take time? They should have
Yo,
took time out of the globe?
the most
Bro,
Yo,
Coffee's
retarded
trying
thing
to
I've
take
ever
my
heard.
lunch, bro.
it's
Stop trying
their
to
No.
take my
sky,
lunch, bro. You can't have my
their
lunch, bro.
star,
Hmm.
They have
their
unlimited power.
angles.
Now they have time.
Bro, that's all he's doing. He's taking our timing backwards, deriving the flat Earth math to match it. That's it. And then
Wait, you
skewing
Bro,
realize
the
these are
That's
variables
corresponding
in
to
between it.
actual observations, right?
That's why it's so easy for me to and Jesse to come up to the same conclusions. And I only spoke to Jesse last week.
dude. That's the
bro,
exact
what are you on,
antithesis
dude?
of the truth.
Yeah,
Need
you
the
just
same
reversed
beta
this whole thing,
blockers
bro.
you're on or whatever the fuck. How the fuck? This is
Hey,
crazy.
Coffee, that's crazy, bro. You realize there's the most important player here
Somehow
is
me,
the
John, and Jesse
real
came to the same
timing.
conclusion.
No, wait,
Somehow.
Coffee, wait. Here's what I want you to understand: that the most important player here that's taking center stage is the only time. It's not your time, his time. It's the actual time of an
Exactly.
actual observation. That's the main player. That's the most important key piece of thing we need, information we need to focus on. So that's not yours. That's just objective. That's what was observed, right? That's the observation.
Yeah, the timing is
So
the
how do you get
measurement.
to claim that as yours, right? That's what I'm confused about. Why are you saying That's the only thing that's real is the real observation, right? And now we're gonna juxtapose that versus your prediction, next prediction.
But that's why
So
he had to backwards derive it, and he didn't just work it out and just get the prediction from Stellarium or somewhere. The
Bro,
only
Dude, what
way
the
you could
fuck?
fuzzy the math is
Empty,
to
bro,
take the
what?
time and
empty,
apply the math to it.
You don't
empty
Coffee, you
backwards
are
rhetoric,
derive.
dude.
misunderstanding what is being backwards derived.
Yeah, you don't backwards derive the observation in time. You just make
That's
that
right.
shit, right? Like
we're
you
No,
gotta
you
yeah.
comparing
take
If you
the
want to
timing,
clarify,
you backwards derive the math to
coffee,
confirm the
coffee.
timing.
Stop
That's
for a
that's all you're
second. Just
doing.
listen.
no,
Just listen.
this is
We're
ass
making a
backwards, bro.
completely separate triangle to compare the elevation differences after we get the occlusion timing.
He
Do you
doesn't.
understand
He
that?
doesn't know what that now.
Bro, I get exactly what y'all doing. You're taking the timing, right? And you're applying either globe math or
Coffee, are you smoking right now,
trigonometry
bro?
Yeah,
Wait,
to
bro.
wait,
You
wait.
get
Are
like
you
the
you
smoking,
moving
actual
bro?
backwards, bro.
observation. Linnell, you can't even follow this, my nigga. Sit down and
Hey,
just
no,
listen.
I heard you
Like for
inhale. Like
real.
it sounds like you
For
holding in some
real, my
smoke, bro. Are
nigga.
you
Like
smoking?
sit down, yo, bro. Just sit down and follow, please. Like,
It sounds like
damn.
you smoking, bro. I just want to
I'm
know.
not doing the secondhand rhetoric today. Not today.
Are you smoking? That's all I want to know. Are you smoking?
Coffee, the equation, right? The only variable you enter is the distance times the angle that it was occluded times the tangent of the angle that it was occluded. That gives you the difference in meters. That has nothing to do with assuming anything or whatever. The distance is the distance for both models, and the angle is the angle that it was occluded at. When you do a trigonometric function on that, it gives you what the elevation is. We're backwards deriving the rise.
Bro,
That
did he
doesn't.
predict the timing or did he observe the
You're backwards
timing and
deriving the
backwards derive the
observation.
math?
Hold
One
on,
or the
You
coffee,
other.
can't
coffee.
backwards derive
I
the
got you.
observation, Coffee. That's what you're
Listen,
claiming.
Wait,
That
wait, I
they're
got him. I
backwards
got him. I got him.
deriving the observation. That doesn't make
Check,
sense.
Bro, that's not what
check
I
it out. There's
said, bro.
two.
You're
No, but
skewing the
Coffee,
that
data,
coffee.
my
is
nigga.
kind of what you're
What?
trying to say. It's what you're trying to say
Bro,
here.
if you think that's what I'm saying, you're not following, bro. Like,
Oh, wait,
seriously.
coffee. I got you. I got you. Listen, there's the timing, right? And when you backwards derive it, right, you get two different elevation heights of the mountain. Which one does it match?
Exactly. And the
That's it,
fact that it's
bro.
matching
Which
flat
one
Earth
does it
can't.
match?
The fact if it matches flat Earth, it can't be because they backwards derived the observation, right?
Can I finish, my guys? Can I just finish?
Yeah, yeah. Let coffee go.
He's taking the timing, right? And backwards deriving the math. He didn't predict the timing, mind you. He didn't use flat Earth math to predict the timing and then make the observation and check stellarium if the timing and the elevation heights match. No, he didn't do that. He took the timing, right, the observation, and he looked at the flat Earth math, and he did whatever he had to do with the values just to make it match the timing. I could do that with the globe Earth math by
What?
just
See what I'm saying?
accounting.
You are saying that he's backwards deriving the observation. That is
Hold on.
exactly what you're saying.
I
See what
got an
I mean?
idea. I got an idea. Wait, coffee. Dr. Mike, could you
Yeah,
please explain the method since you're here? If you don't mind, since you're here, I'd like you to participate if you can.
and we apologize for making you do it again.
Oh, no problem. And I
I just
actually
need
think
him to.
Kamal did
Actually, it
a
just need
great
him to
job.
answer one question. Did he
Wait,
predict the
coffee. Let
timing?
him. Hold on.
Let
Let
him
him
Coffee,
explain
explain.
the whole.
not
Yeah.
interrupt.
Let me answer this question before we go on to something else. But when you see the peak occlude the star, you know that a physical object blocked that starlight. Um, there's nothing backward derived. The next step is you look up the elevation of that star. What was the elevation of that star? And to oversimplify it, I was expecting 2 degrees 17 minutes. That was the globe Earth prediction. But what I got was 2 degrees 31 minutes, which is the flat Earth prediction. It's got to be one or
How
the
did you
other,
get that, Mike?
unless we're on a concurve Earth or something. But those are your two options. So I
Mike, how
intended
did you
to.
get that? Because when I take right the 231 observation, I'll subtract the curvature drop from that, right, in degrees, and then
Who
translate
told
that
you
into
to
arc minutes.
subtract
I get
anything from that? Hey,
217.5.
coffee, calm down. You're
Bro,
doing it
it's cool,
wrong.
but you do gotta let me finish.
You don't
That
subtract
that
anything. You've
bro,
got
that
one angle or the other. At the
I
time
hear
of
you, but for the
occlusion,
globe prediction,
that
correct?
star
Are you not? You gonna let me finish, my brother? I'm sorry, it's getting frustrating.
You're just spewing nonsense, Coffee.
I hear you. I hear you, my brother. But
Can we go into my
you
depth?
could just wait till you
You're
could just
just
wait till I'm
spewing
finished and then
nonsense.
tell me it's
How do you
nonsense.
interrupt everyone
You
and
are
then
very, very
complain
confused.
about it? That's ridiculous.
Yeah, how about we let the guy who created the method explain it fully to you?
How about we just let me finish with my rebuttal and then just let him finish real quick?
You have no rebuttal. You're just spouting nonsense. You don't have the slightest idea what's being done.
Okay, so let me just finish. I got you. So
Yeah, just
when
finish your nonsense.
okay, so when I subtract the curvature drop, right, from the observation, I get to 217.5, which is closer to the observation, right? And is that not global closer to the globe prediction?
No.
Coffee doesn't even make sense, man.
Yeah, you know
Now,
this
So
now
right,
what
you
I
Paul.
have a
Am I
hear you
not
ref-
So
saying,
am I not bugging? He did not just
hold
say
on, guys.
the globe
if I can
prediction was
still man
217,
your
right?
position,
The
I think
So
I hear
observation
you
was
saying that
231.
coffee.
what
How
I
did
I
hear
you
you
account
saying,
for the
Coffee, is
curvature
that
drop in your
217 is closer
observation?
to
All right, guys, hold
231 than
on.
231 is.
Copy, you finish your sentence. Now let Mike respond, please.
No, he could go ahead. I want to hear what you guys say. Go ahead.
What I hear you saying, Coffee, is that 217 is closer to 231 than 231 is.
That's
That's
what I
not
said.
wrong.
You're
That's
right.
not right. That's nonsense.
No, my bro, see, that's how I know you're obscure. You're obfuscating right now, right? The reason being is
You
that
have
the
no idea
observation.
what.
How did you get your 231?
You
How
should
did you
check
get
your
your
blood. You
231?
should check your blood sugar, bro.
Yo, oh, real quick. Here's a better. Here's my analogy. What it seems like.
hold
It's
on, hold
like
on,
there's a guy. Look, real
Real
quick.
quick,
Hold
like,
on, Coffee. Now, hold on.
because
No, no.
he,
You've been going in circles. Hold on. Let
hold
me
on. I
bro,
gotta
let
ask
me
Dr.
let me
Mike a
tell you how I'm
he's
interpreting what
dropping the
I'm
metal.
hearing.
Let
Right?
him respond to my question.
Yeah, but he
Let
seems
him
uneasy. It
respond
seems
to
like
my
you're running
question. How
around like
did
you're.
he get the 231?
Hey, Jamal, can you
All
hear
right,
me?
go ahead. Let him respond.
Yo,
Yeah.
we're done with that. This
Real
is
No,
quick,
we're
if I
not
still
done with
just want
that,
let
bro.
me
You're
just
not
get
just
my
gonna
little piece
tell
of
me you're done
this is
with
what it
that, bro.
sounds
You
like. Real
could go
quick,
home
Coffee.
if you're
Hold
done.
on, I'm gonna let you go.
Hold on.
Like, give me 5
Like
seconds, bro.
I was asking him simply, what was the 231 for? How did he get it?
Octane rise
How
over
did you
run.
get
Straight,
the
bro.
That's
231?
it.
It's literally
Octane
just
rise over
Straight,
run.
bro.
arctan
Done.
Raw
rise over
trig.
run, bro.
Raw trig
Exactly my
analysis.
point. You did not account for the curvature drop. So when you account for the curvature drop in the observation, you get
Hey,
closer to the
Coffee,
globe prediction. It's
No,
just
Coffee,
simple
Coffee.
shit.
Coffee.
So
Coffee,
He's
make a
hold
dancing
on,
flat.
hold on,
Wait,
around
hold
wait,
on,
like
hold
this
on,
wait.
is
hold on,
not
hold on. Let me
true.
ask
Oh
Mike a
my god.
question. Dr. Mike, do you need to account for do you need to reduce by that curvature drop or not for this thing to actually be accurate?
No, you do not. You look up the elevation of the star. The elevation of the star is whatever it was at the time the peak occluded it.
Okay, so coffee, there
That's it.
The
you
peak
don't
is
need
not
to do
affected
that.
by curvature drop.
That's
In
why
my
there's
But
three
model,
I
it
know
does
if
Not
not.
on
predictions.
the flat Earth
if we
prediction.
measure
No.
if that's the case,
231,
I'm
then
not
you have a
talking about the
refracted
flat
He's
earth
amount.
talking about the
prediction. I'm
globe
Coffee,
talking about
prediction.
in the globe model. Because this
hey,
nigga dancing around right now. He tiptoeing.
coffee, I
Nah,
got
we're gonna keep him right in place.
231.
Here,
For the
Alan, I
globe
got. Let
model, do
me
you not account for the curvature
coffee,
drop? If I was to
coffee,
observe that accounting for the curvature drop, would I not
coffee,
apply that
in the globe
203
model.
Petty.
meters?
Bro,
No.
coffee.
what?
Hold on one second, please, please. Coffee. How would you make a flat Earth prediction? Arctan
Which
over rise over run, right?
Zero
How would
triangle.
you make a
yes,
globe Earth predict? How would you make a globe Earth prediction?
Mm.
same one minus the curvature drop.
All right.
Well, that's what he's saying. He's asking Dr. Mike, is he accounting for that curvature drop on the globe model prediction that he's using?
Yes.
D3.
No, not for the globe model. But this is the point that nobody's following
He
this shit.
wants you to
Okay,
Everybody
turn.
seems
doc,
lost.
No,
Hold on,
he
so
let
which
me
wants
one
to
is
just
it
turn
fucking
the
for,
finish one
flat.
coffee?
second. Let me finish. And
Which one
nobody's
is it
fucking
for?
following.
Which one
The
is it
point
for?
is he made an observation, right? The
Right.
observation is the independent variable, right?
Okay.
Now he proclaims that that observation is 231, right? Now you have to apply the mathematics to confirm that observation. What I'm saying is if I
Okay, that's
apply my
incorrect.
globe mathematics to that observation, it comes closer to the globe prediction.
Which
So
one,
how do
coffee?
we confirm the rise over run
No,
minus the curvature
that's
drop? Come on,
Which
my
one,
niggas.
that is
coffee?
incorrect, Coffee.
Which
Coffee,
one?
let's back it up. Your comment about how it's the independent variable tells me that you do not understand the term. Okay? The
Mm.
independent variable in this case is the distance from the mountain.
No, it's not. It's the
Every
timing.
Exactly.
Fool.
Jesus
It's the
fucking
timing. The
Christ, Coffee,
timing
would
is
you shut
regardless of the
up?
matter.
Hold on,
Shut
let him
up,
talk. Let him
Coffee.
God
damn, could you hear what I'm saying before you
Coffee,
object
you
to it?
came in hot today.
Okay?
For what it is.
Look, man, if anybody would take the time to study the terminology used in an experiment, the independent variable is the one you control, and that is your distance from the mountain. The other ones are dependent variables. Continue.
The relative elevation.
Yo, Mike, am I bugging? Is the independent variable in this experiment not the timing?
No, because you don't control it as
I'm asking Mike. I'm
okay,
asking
okay,
Mike.
okay, okay.
The answer is no.
There you go.
Yo, man of stone, I'm not asking you, my brother. I'm asking the man who carried it out.
Put your axe away and learn some English.
You can't
Be
be an
nice.
ex.
I think we can all be calm and be nice, but
You
the
got
the
it, Dr.
point
Mike.
is, yeah, the star is occluded at some angle.
You
Um,
see, this man not answering
the
no questions. He dancing.
Bro,
Coffee, shut the
bro,
you're
fuck
not
stop.
up.
you're not
Interrupt, bro.
listening to my
Stop
answer. You're
interrupting,
Chill.
dude.
interrupting my
You
answer.
too hot today,
Let
bro. Chill.
Yeah, just relax, bro.
We'll get through this.
So the star is occluded at some elevation. The flat Earth um, prediction is that elevation will be 2 degrees 31 minutes. The globe Earth prediction is that angle will be 2 degrees 17 minutes. So the question is, which is it? Well, it turned out it is 231, which says the flat Earth prediction was right. The globe Earth prediction was off by a significant amount.
My
Okay.
question is, how did you confirm that observation was 231? That's my question.
That
You
was
make
the
it.
elevation of the star at the time of occlusion, according to the Nautical Almanac.
Or
So
you
you
could
don't
throw out
take
the
a in
nautical
so
almanac.
so
That's fine.
for my model, I don't take in the count in for the height of the peak, the difference, right? The change height of the peak due to curvature drop.
Well,
Coffee. The
apparently in the globe Earth model, you have to account for everything. In the flat Earth model, we just look at what the elevation actually was.
Coffee.
So you're
In
confirming that this observation confirms nothing for no one.
coffee. In the actual
Because
drop
if I
over distance formula, we multiply it by the distance. So how do we account for it? Literally directly. 360 times
do
50,700
you
meters
drop the
over 2
peak,
pi
the
r.
elevation of the
My
peak,
God.
the peak has an elevation, right? Given in the sky, do you drop that elevation given the curvature drop?
Why? Could you explain the rationale behind why you think that should be done?
Because I believe the Earth is a globe. If we could find a way to confirm the
I don't
elevation of this
understand.
peak
But you're
given the
asking
observation,
someone who's good.
then we could find something concrete. If not, then it goes either way.
So
It just
okay,
matters
coffee.
whether I confirm curvature or not.
So
That's all
okay,
that matters.
coffee. So either a refracted mountain blocked the light of the star, or it was a physical object. So that's
Mm.
what the
Bruh,
determination is right there,
enough
bro. What do
of
you
this
mean?
blocking. If you see the occlusion, if you could see the occlusion with your eyes, that means that event, the light from that event is reaching your eyes, which means it could be
Until it's
No,
refracted.
not.
it's the opposite
No,
of
it is
that.
not reaching your eye because
It's
it's
the
Until
opposite
blocked.
of that. What do you mean?
until it's not, coffee. You remember when you
What
can't
in
see
the
it, right?
fuck?
Opposite of that
Is
again.
the occlusion not an event?
Yeah, I
Do you
understand what
know what the
Coffee's
word
saying. He
like?
just means
You
that you see the
observing the
event happen.
event,
Hey,
right? So the
Tessie.
event,
Coffee.
the image of the event can be refracted because it's a
Coffee.
path of light
No.
coming to your eyes.
One
He's
second.
going off like the
Can
whole
you guys hear me?
Canada thing. Like the whole
Oh
Canada
no
thing is
no.
Let's let
refracted as
Alan.
well.
Let's let
Can
Alan
you hear
get
me?
in. Yeah. You're just
Coffee.
coming in low.
Yeah, sorry. On the globe, the positions of the stars is equivalent to time. Like the angle is equivalent to time. So the time of occlusion is equal to an angle. So if the refracted image blocked it because the Earth is a globe, then the time would be different. It wouldn't be the same time as if the Earth was flat, because our prediction is that we occlude it sooner because we're saying that the physical mountain peak is higher regardless of what you optically see. Because there's two different uh, ways to view this, right? Our argument is that the curvature drop is optical and it's apparent. It's something that you see through your eyes. It's a natural function of optics, where you guys are saying that it's physical. So this is a test between the two, because the timing differences is what we can use to multiply against the distance to get the elevation, because the elevations are already known and published, right? So we go and look those up, and we can translate that angle of occlusion to and multiply it by the distance and get the elevation in meters. And that's what we're comparing, because if the
That's the
Earth is a
backwards
globe,
deriving,
Right.
by
yeah.
the way.
And so, Alan, for that, you
Yeah,
don't
but he
actually
didn't
need to do
predict
the
the
drop.
timing. If he
Well,
predicted timing, that would
we
just nip this in the butt.
you don't have to, and
Now
you
you don't have to. Yo, y'all salsa really well, my guy. Y'all dance really well.
You observe a timing. That's the
you
only thing you
observe the
do.
time,
Like, geez,
It can't be predicted.
like you, you can go
everything
anywhere
else is
and do it.
predicted. That's the
Can
only
it
thing
not be
observed.
predicted?
Why would you?
Everything else is, dude. So that goes in. Well, so what Stone brought up about the difference between the independent variables there is like, this is exactly what's important, because the one thing that we're watching is like that's the observation. That's the thing that changes, right? That's going to change per location. But what's not going to change is the distance and the elevation, because those are all published and known. So we can make direct comparisons between the two models. So when you're saying, are you accounting for the drop? I get what you're saying. And let me steel man what you're saying here. If you're saying that if we had a theodolite at the same time looking at that mountain, it would come out to be 217, but the time, right? That's where the difference is, because the time equals angle, right? Because optically it's going to look like 217, but the timing in which where that star is purported to truly be, so that it could be referenced through corrections to be useful for the globe, is what does the occlusion.
Real quick, Coffee. This is
Alan,
what
that's
I'm
what.
hearing from you. Real
Go
quick,
ahead,
Coffee,
my
'cause I've been
brother.
trying
Go
to
ahead.
get this
Go ahead.
analogy off, right? This is
My
what I
bad, bro.
think
Go ahead.
it comes down to me, right? It's like we have two different predictions, right? I say, hey, based on how I think we see things and how things work, this guy's 6 feet tall. So I put a marker on the fucking door, and I say he's 6 feet. He say no, he's 6'2" based on how I think we see things and how it works. He walks through the fucking door, and his head just lines up with the 6 foot marker. And you're like, nah, you just backwards derived that. Bro, that's what the fuck? It doesn't matter. He is 6 feet. Like, the only way it works that we see him at 6 feet is if he's actually 6 feet. And you're saying he's 6 feet doesn't match. You're just wrong, and we're right. I don't see how you don't see that, bro. You
Because
can't.
tis
Yeah,
globe, buddy.
I don't see how y'all don't see the prediction of a timing would nip this in the butt. I don't see that. You feel me? Because it's just like we just went over. I can observe it, right? And put the timing, right? For the globe timing, right? Because I believe the earth is a globe. So the timing for me is a globe timing,
You can't observe it
Just
at the globe
right?
timing,
empty
though.
I would
You
have
can't
to
do
Coffee,
that.
prove
rhetoric.
through prediction of that timing, given the elevation height, right? And the distance and the motion of the star, the timing. I would have
yeah.
to predict that in order to confirm that my
So,
model's math equals up
oh,
to that timing. I
coffee.
can't
I'm sorry.
backwards
I'm sorry.
derive it.
Coffee. I misunderstood. So earlier when I said the angles equal timing, our angle is also the timing, because that's how you can go into stellarium and reference where it was at that time to get the angle. They're equivalent, bro. So we did nip it in the bud. It's nipped in the bud. That's the entire point of this. That's why it's so significant. The globe is constructed off of corresponding time to angles to the stars. So
Hey,
our
Coffee,
angle
you
is a
notice,
time.
Coffee, you notice he's not using the same colloquial as you. It's not nip it in the butt. It's nip it in the bud. It is a botanist term.
Okay,
You're a
Alan,
weirdo, bro.
I think that
Dude,
was the
Stone is
crux of it right
literally
there.
quality of assurance no matter where he goes. It's fucking crazy, dude.
Coffee, did
It's
you
the
get
little
what
game
Alan
I
just
play all
said?
the time. It is called Expose the Idiot.
It's called you're a fucking weirdo, dude.
Coffee, did you
Hey,
get what Alan
I'll
just
take
said?
that.
Stone's
I'll
still
take
butthurt
that.
from my last back and forth, but
hold
it's
on one
cool.
second.
Oh, you
I'm gonna let
sweet
him
Deviate.
lick
denial
his wounds
still,
over
hey,
there.
Coffee? That's
Yeah,
Hold on.
let's, well, hold on. Yeah, let's stay on the point.
Let's not deviate from this.
Yeah.
So Coffee, your contention was that we didn't have a timing prediction, but our angle corresponds to the timing. So we do. Like they're literally equivalent. So
My
you're
angle could correspond to the timing.
No, it doesn't.
What are you
you're
saying?
It never
No, but
could. That's why it
All
but
I
would
you're
have to
never.
wrong.
do is subtract the curvature drop. That's it.
no, but see Coffee here. Here's the difference. The time that the star was occluded only happened at one time. So it only happened at one
Yes,
angle.
Exactly.
exactly my point. That's why it has to be predicted.
No, bro, you
and
can't have
we
my lunch.
and we did predict it. That's the angle is the time.
Because if you didn't predict it, right,
We
then
did.
all I could say is that you're
I just
taking the
can
globe
you hear
timing
me? I
and
said
just
we did.
applying your flat Earth angular height to it. That's it.
Coffee. Is the globe constructed off of converting angles to the stars to time and vice versa?
Yes, but you still need to predict the timing because that
Okay.
changes
Okay. One
on your
second.
model.
No, it
The
doesn't at
angular
all.
Hold on, wait,
heights don't
wait.
match
Coffee,
up
let
with
him.
the same timing as the angular heights on the globe model and its timing.
It
Doesn't match
doesn't.
up.
It exactly. It only matches the
Exactly
flat
my
Earth
point. So you
prediction,
have to make a prediction to
dude.
show that your
But
We
Coffee,
angular
we
height
did.
matches up to the timing.
there's only one
We,
timing that matches reality, dog.
Yeah,
That's what you're
you're
not
exactly.
getting.
the
So why
spreadsheet
not
shows
make a
the predict
prediction to it?
coffee. The
Can it
spreadsheet
not be predicted?
it's literally in the angle.
It's been photographed, video.
The angle is the prediction. It has that is equivalent to time. That's why when you look up stellarium and you look
Degree
at what
formats.
time. So coffee, you realize that when you go into stellarium and you enter the time that it was occluded, the true position of the star is at the same angle that is predicted for a flat Earth.
It might just be a coincidence,
Right.
or
You got to understand that the angle is the prediction, like he was.
Time
I mean,
equals
even
angle.
John, kind of even like would say, hey, that was a coincidence, right? He didn't disagree with the number. He said, oh, it was some foolery,
Yeah,
some
nobody does, which
tomfoolery.
is the funniest part. Nobody except Coffee
yeah,
disagrees with this in the
you
Glober
can't.
community.
If you
Listen,
disagree with
coffee's
the
contention is
angle,
legitimate. Coffee's contention is legitimate.
I,
It's based off of a slight misunderstanding.
I agree.
I disagree.
No, well, that's fine, but he
Can
acknowledged that angles and
you
time
still
are
man him?
equivalent, so we're good to go.
Can you still man him, Alan?
Yeah, he wanted to. He thinks that we should subtract the globe difference off of the occlusion timing, which would give the globe timing, but the occlusion timing is the physical timing that it happened. So, like, that doesn't,
Okay,
that's not something you would do in the process.
that's what I thought. That's what I thought.
That's changing the
but
time.
to reinforce that point, Coffee, think about it, right? It's only a one arc minute point source of light. So like if we were to do that, it'd be like 14 arc minutes off from what reality showed.
Mm.
You
That's
understand?
what makes the allowance you're asking for so absurd. I think is that we're
Exactly.
literally dealing with like the smallest little corridor of light, like a single pixel, and then you're claiming that you can precisely refract it just where you need it to be. It's like,
Fo-
come on, bro.
14 arc minutes is
A-
56 real time seconds, bro.
And just to clarify something for a minute, Stone, the distance can't be the independent variable. The reason being, right? If I was to change that distance,
Wow.
right? I mean, if I change a position given the same distance, then change the timing. That
That
can't
is
be the
absolutely a nonsensical statement. You change position, but the distance. What the fuck are you talking about?
You're still looking at the same peak, bro.
The independent variable
you
is
change. See,
elevation
this is the shit.
angle.
My bad, Sydney. This is what we was talking about last time y'all were here, and I was going back and forth about this with Shane and Alan. Right? It doesn't matter, right? If you're along a 360-degree arc along that middle point of the mountain peak, if you change the position given the distance, you could keep the same 50 kilometers. But if you change that position a degree, you then change the timing.
That's not exclusive to either or model.
Yeah, our angle would change too,
That's
dude.
literally doing it in a different spot. Like, bro, coffee, you
You're
gotta
grasping at straws, bro. Hey, I'm
like
smoking too, bro. Light one
like
up. Let's chill out. It's
like
fine.
on like for real. I'm sorry I yelled at you earlier. I got really frustrated, but then I realized what your contention was. I was actually dealing with some or talking to somebody on Monday about the same thing, and then I realized like, okay, so what you're conflating is like you would want to change it optically, which would change the timing, but the timing there's only one timing. You know what I mean? So you that's what we're referencing because the time itself is equivalent to the angle. and that just happens to match what the flat Earth predicts for the for the elevation angle.
Yeah.
That's why the timings are mutually exclusive per model.
How do you get the angle, Alan?
Rise over run, arctan over rise over
Exactly.
run,
How do I get the angle on my model?
minus the globe drop, 69
So if
degrees
we
per
both
minute,
made the same
minus gravity.
observation, our output values would be different, correct?
The timing of occlusion would be different, yeah.
No, no. You see, Coffee, what would be different would be the figure you're
No,
looking for in
the timing
stellarium.
would stay the
Can you
same.
fucking
Hold
The
shut
on,
up
hold
and
on. What
timing
listen
Mike
that we
was
instead?
saying, what he was saying real quick. Let me hear what Mike said. What would be different?
The difference here is what you would be getting back in stellarium from the dependent variable. You know, when you, whether or not you opt to include this global compensation for rise over run and you have a different drop, that means that you would get a different time from stellarium, and you don't. This is the whole point of the exercise.
But 'tis globe.
So, like, let's just be clear. Like, the distance from the mountain is the control variable. It's not the variable
No,
of
the
change.
distance
It's
from
the
the mountain is
constant.
the
The
independent
independent variable
variable.
is the elevation angle.
No, that is
No, you're a
dependent.
Same thing.
clown, dude.
Distance.
The independent variable is the elevation angle.
The angle depends on your
On the
distance from the
distance. What's the
mountain. That's
difference, right?
the
I don't
Bro.
understand.
independent variable.
Oh my God.
Hello?
Dude, the
Go
control
go back to the
variable.
books,
Are you
bro.
standing in one
Jesus.
spot while you're making your observation?
Of course you are, but you have to
Okay, that's the
pick the spot.
control.
It
You gotta
That's
pick
has
the
the
a
spot, bro.
constant.
distance value.
That's the constant. Dude,
No,
I
it's
will
not.
I will
You
fucking
where
beat
your
you up on
location
this.
is
That
the
is the
independent
constant.
variable.
That is the constant. You are wrong. The
No, no,
independent
it's not.
variable is the elevation
Man,
The
angle.
constant is the elevation of the
Bro, you're
mountain.
so
That is the
off. You're so
Stone.
constant.
off.
All you
That's
gotta
why all
do is
you
do
can
the
do is
math
talk
for it,
shit
my
about
brother.
the
Just
way
move the
people
Jesus.
speak because
position
you don't
along
know
a
what you're
three.
talking about.
Oh, this is tragic.
Regardless of what's constant and what's the variable, we need to
Yeah.
focus on the result.
For
Yep.
And Coffee
me,
had a
What was the
contention
result?
with how the result is derived because you don't do the drop. But I don't. What Coffee's not understanding is that you don't need to do the drop.
Well,
I
we
don't
already did the drop. The drop
understand about
results in
not.
different time.
Yeah, I don't know why we're specifically accommodating the drop over that distance in your prediction. It
Yeah,
specifically accounts for 27 arc minutes, right? Everyone agrees on this. I don't understand why you think you can subtract it and then add it back again at the end or whatever. Like, I don't understand what you're talking about. I don't understand your contention at all. I think it's retarded.
you
I'm
want your
talking about
cake
the
and you want to
elevation
eat
of a
it too,
peak
bro.
and its
Uh,
elevation height.
yo,
That's my point. Because
if
the
there's no
star is being
further
occluded by
questions,
the peak. The peak has
we're
an
we're
elevation
gonna get
height,
out of
right?
here. I'm gonna go do some other stuff for the night.
Yeah,
Sounds
I'm good.
exhausted.
I'm good.
Yeah. Thank you guys all for coming out. Thank you for having us. And if you guys aren't on the Flat Earth Gang Discord, there's you're missing out because there's going to be resources that are going to be left there so everyone can look at the data. They can look at uh, the slides that we referenced earlier so that everybody can get familiar with what we're talking about in regards to these angles and these timings. And tune in Sunday to Globebusters for Mana Stone's analysis on shadow sets regarding the old sun and some more trigonometry.
Should
Ooh,
be
you got an
fun.
update to it?
Hey.
Nice. I want to see that.
Yep.
that's more like just a recap. There isn't much more to say.
Except to
That's fair.
invite more lads to get more data.
Exactly.
Nice.
Cool. Thanks, everyone.
Yeah, so guys, if you guys want to participate in the celestial theodolighting, all you need is the ability to record stars at night and be able to distinguish the peak. And the best way to do it is go somewhere where you can like where you can line it up with the peak exactly. But if you can't do that, you get a ridge line or whatever, like that's fine. You could figure it out later. But all you need to do is get your coordinates for where you're at, so your latitude and longitude from where you're observing, and then get the coordinates for the peak that you're observing. So that's why I said it's important to kind of get a peak or to start with, so you can get the exact distances and everything later, so you can figure out what you can do all the math stuff on the back end. All you need to do is record. So if you guys want to go, if you guys have the equipment, go out, record peaks at different distances. Doesn't matter. Pick them. The more data, the better, as Stone says, and just give us the coordinates. We can do everything else. For you guys.
Can we get
That's a
a worksheet?
hold on, wait a
Do it
second.
like a homework assignment.
I want that to sink in. You don't need the distance because it actually works. The angle actually matches. That's crazy.
Right, dude.
That's insane.
These,
Do you
these,
guys
that's
realize that?
that's the beauty of this, dude. Like that's why this is GG, man. They can't make it without obfuscating, refracting it on the back end, what they already accounted for. All
But I
like it's
believe it's a globe. Give me my globe back.
hey, man, it's all good, man. It happens. But yeah, dude, what you just said though, what you just pointed out, Beast, is extremely significant. It is it is what distinguishes the mutual exclusivity between the two. So all they have is a conceptual model based off of a fictitious observer. We can disprove that by recording stars occluding peaks.
Yeah, that was all pretty profound. Like for me to get that, truly they are putting you at. It does rely on a radius and you being, and the presupposition of that geometry and that radius, and from that position of the center of that thing is what this all relies on. Like and
Dude,
that's why something.
that's why I encourage if anyone is south of the equator, please contribute. I would love to see some data from south of the equator for sure.
Dude, we need some southern lads. Like, we're always arguing, is the South bigger? Is it symmetrical? Is it like, what's the deal? How they fudging it? Southern obs would help a lot.
My
For
problem is I
real.
just don't have the topography down here. It's so freaking flat in Uruguay. I can't help you. Sorry.
You
Dude,
need to
yeah.
build a mountain stone.
Is there a really
It will
tall
come.
tree somewhere?
Yeah, for sure. Got to build an artificial mountain.
Yo, but Stone, what about like a wall? What about a nice west-facing wall? Has anyone devised like a really control? I saw you did, use your like the little peep window in the fucking in your garage or wherever it was. Has anyone just like set up an Eratosthenes style sticks and shadows?
Well, I think part of the attraction here has to do with eliminating as much refraction as we can, and we do that by using a peak that's way up high where the air is
No, no, I
not
meant
so dense, right?
for your shadow set
Oh, for
thing. Like,
shadow.
yeah.
Oh, use it absolutely anywhere. Anywhere, just light passing through something, hitting something else feet away. No, absolutely, that's all it takes. For me, we were talking about 6 meters or whatever the hell it was from the door to the wall, right? So I get a really crispy angle measurement, right? The error margin goes down the farther apart those two fixtures are, the door and the wall. You know what I mean? The farther apart those are, the more you cut down on your angular margin of error.
And you can just see that sun just fade away, baby. Just fade away.
You got
All right. Thanks, you guys. That was awesome. Coffee.
No, good
Light
stuff.
one up for me, bro. I'm lighting one up right now. You're good.
I got you, my guys. Yo, good shit, y'all. Always a pleasure. Y'all already know it's never nothing personal. The heat is never nothing personal. It's just in the spirit of the back and forth.
Respect, respect.
Well,
All right. Thanks everyone for coming out. Much appreciated. If you guys like what we do here, my coffee is in the channel description. Thank you all. We'll see you guys on Sunday for Globebusters. Make sure to tune in to that. And then we'll be back again on Monday with Celestial Theodolite number 13, I believe. And then we will get into, then we'll have a presentation on the following Tuesday for Ether Roundtable, number 94.